Guys, thank you very much for coming out tonight. We have a strong group here. I was in Connecticut last night, a little disappointed. 17 guys. It's a shame the guys don't want to come out and learn stuff and keep up with times. In Massachusetts, we have 40 guys. Here we have like probably close to 70 guys. So I appreciate all you guys taking time to come out. We probably had more numbers, but of course we have our new inspection program ordeal going on tonight. I believe somewhere in Wayne or something. So that's why a lot of guys couldn't make it. But again, I appreciate you guys coming out. This is something I worked on a couple weeks ago to put it all together. Probably spent 30 plus hours on it. I want to give you guys a little taste of different aspects of the automobile. Not just drivability, doing engine performance stuff, but try to bring it all across the boards to give an appetite for everyone, to let them know, don't just hone in on one subject. Because a lot of these new cars today, BMWs, Mercedes, they have 50 plus controllers on them. So what are you going to diagnose? Just maybe ABS and the engine computer or trans computer? There's a lot more computers out there. So I'm going to help you build a foundation of how you're going to tackle these computers and show you how they all basically have the same baseline of going in and doing particular checks. A lot of you guys already know I drive around the Hummer. It's very fuel efficient. My home heating bill was about $2,200 last year. My bill for my gas on my Hummer was $14,000 last year. But hey, it takes me where I gotta go. It's my problem, but it's a good problem. Yeah, I'm gonna hybrid it soon. This is not a class on identifix where we're gonna have a problem and a fix. This is not a silver bullet of what I can do to get this problem resolved. This is the smoking gun of the silver bullet. I'm gonna let you know how we go through each step procedure. And if you already know the answer, don't give it out, because we all want to learn together and see how we got there. That's the most important thing, is how we get there, things we check. And I'm going to tell you something. I'm going to say maybe, 10 years ago, I wrote this book. It took me 1,500 hours to put it together. And I used to use a machine called Simutech. And Simutech taught me how the computers worked, starting with power feeds and grounds for the computer, going into what the computer is going to give out as far as powers and grounds, and all the sensor inputs, and what it's going to do as far as controlling devices through driver circuits. And then there's strategies. And that's what I built in here. And I learned from it. And my first 2 slides came out of that book, and I always, even when guys come out for boot camp training, I always says, you got to know these 2 slides, because this is the foundation of what's going to happen down the road, and I'm going to prove it through each case study. And that's why I want to go over some of this stuff. I don't care what kind of computer you're working on, whether it be ABS, airbag, engine computer. Every computer is going to have a battery feed. And it's for memory, right? Or to power up the unit, but it's also for memory. So when you shut off that key, it still retains information of things it might have learned. And they also have in these computers something called non-volatile memory, stored in the chip, that if you disconnect the battery for a day or 2, it still holds the information. But I'm finding out if it's disconnected for a long period of time, and I don't know where it is, but it could be more like 3 weeks, a month, then you're married to doing a lot of things in these cars, which we're going to talk about. So the non-volatile memory is very important. It's memory that's held, and you can't jar it loose. Kind of like with my ex-wife has. She has non-volatile memory. She can remember the day, the hour, and what happened. All right, so that's non-volatile memory. I try to reset it a few times. It's just not going to work. Disconnect our battery cables. So understand that non-volatile memory sometimes may require a scan tool to reset it. All right, so that's battery feed. You're also going to have ignition feed. That's the wake-up call. So when a computer is dormant, all right, it's sleeping, waiting for you to wake it up. And the way you wake it up is by turning on the ignition switch. Any computer. You turn on the ignition switch, it's ready to go. Some manufacturers resort to power relays. And I'll tell you, the ones who use power relays, they fail constantly, because there's no guarantee when that field coil is energized and the contact's closed and you hear a click, there's no guarantee you're getting full voltage. You could be getting 10 volts. You could go down the road, hit a bump, and the contacts will bounce. These contacts can pit, especially if some of these manufacturers, what they do is they'll put the ignition coils, the injectors, all in the same relay, the relay contacts, which is just bad design. So understand, when you turn on the key, you want to check at the controller. Don't go out here to the fuse panel, because that's the horse's butt. You'll be crapped on. You have to go to the horse's mouth right at the computer for anything you're going to test. And if you are going to test it, you want to crank the engine. I kid you not, I've had bad ignition switches where you turn the key on, you got power, you crank it, you lose it. So you want to test power feeds, always go to the computer, crank the engine, and then check for power and battery and ignition feed while you're cranking. I've had cars where car won't start, cycle the key a few times, starts up. What do you think that's going to be? A relay, which is common failure. The other thing too is ECM grounds. Very, very critical. Some manufacturers run them to the battery. Ford used to do that in the early days. If someone wanted to change the battery and the negative cable kind of broke, was hanging out there, they're like, oh, is this a fusible link? I mean, I should put it on the positive side. And they take out the computer. So it's important to know that some manufacturers did use the battery. A lot of them today are actually putting it on the engine block. So you have to also watch out on engine blocks. You know, you can get corrosion. And remember, anything over 0.3 cranking or 0.1 running, you're going to have problems because you're going to have elevated readings on all your sensors, because the computer will base its ground on where it's going to make its regulation of voltage for the system, which we'll talk about next. So you're going to have a main ground feed, ignition feed for wake-up call, and battery feed for memory. Another thing too is, let's say you have 6 grounds, and you had like a running problem, no start problem. Would you check 1 ground or 3, or would you check them all? Would you check them all? Or maybe just check a couple? Do you know why they have more than 1 ground? Anyone know why would they have more than 1 ground? You think that 1 ground is just going to say, okay, I'll power up the ECM, or they all power up the ECM? Because I had 2 cars burn me over the past couple years where the car had no fuel pulse. And I go in, I had communication, all my scan data was perfect, all right? I went in, and I'm checking as I'm cranking, I have RPM signal, battery feed, ignition feed, I have no pulse. I could pulse the injectors by grounding the wire, and I could not understand why there was no pulse. The security system was working fine, so I said, you know what? This ECM has to be bad. And all the guy did was he went to a shop, and he had a starter put in. They were hanging this starter. And what they did was, when they were hanging the starter and changing it, they pulled on the harness, they broke 1 ground feed for the computer. You know what that ground feed was for? What it was dedicated to do inside that ECM? It was using it to do something, to ground something. The injectors. That 1 wire was dedicated for the injector driver circuit. So that's why I'm telling you, if you're going to check 1 ground, just check them all and check them cranking. You can do a voltage drop test. Voltage drop test is nothing crazy. People are like, all right, here, a volt just dropped. That's a voltage drop test. I'm going to tell you what it's all about. I'll make it real easy. You're going to take your voltmeter from the negative side of the battery, go right to the computer with your meter, and all you're going to do is you're creating a bridge for electrons to flow, all right? So normally the electrons are going to flow from the negative side of the battery to the ground. So you're hooking up the meter and going, hey guys, come on for the ride, let's go, 0.1, 0.2, 0.3, 0.4, 0.5, and you're counting how many electrons are flowing through your meter. When you're cranking the engine, there better be never no more than 0.3. So let's say you just hooked it up statically, and you got 5 volts. That's a big drop. That's a lot of dudes going down your meter because they can't go the other way. So you're just measuring how many electrons are flowing through your meter and not going the other way. That's what voltage drop's all about. So understand that when you're checking the grounds, don't just check and put it on. You want to crank it, because when you crank the engine, you're going to load the entire electrical system. So that is the best way when you're checking any power and ground feeds at the ECM. The next section is once the computers, I'm going to say processors, whatever they are, get their power and ground feeds, the next important thing is what they feed out to all the sources. So we're going to feed out an 8-volt reference power feed. Where would we use an 8-volt reference power feed? Not reference voltage, but reference power feed to power something up. 3-wire device, crank sensor. Chrysler has them. They use the crank sensor 3-wire. They use the 8-volt or sometimes 9-volt reference voltage. And I'm going to tell you, if that 8-volt reference, which is shareware for more than one sensor because it's 3-wire, if that sucker ever goes to ground, it will put that computer to sleep. It will go in dormant mode until it's alleviated. So it's a very, very important power feed. A lot of computers will go dormant. They will go to sleep, no communication, inoperative. I had one that kicked my butt on a Land Rover. And Nick here, I'll give him credit, he found it. We had thought initially that this computer was an instrument cluster. At times it would just go blank. You checked all the powers and grounds, they're good. I'm like, what's going on here? Tap test, whatever you got to do, check the pin connector, put contact enhancer on it, it's still dead. Other times it come back alive. And he checked every single wire on that computer when it was working, and they checked them all again when it wasn't working. He found out that there was a 5-volt reference feed for a 3-wire system going back to the fuel level sensor in the gas tank. The fuel level sensor in the gas tank, was that the end result? Was shorting out and took the instrument cluster and made it go blank. And you know what? I've seen it for no starts, but I never saw it on an instrument cluster before. It blew my mind. I'm like, Nick, I got to go home and think about this one. So then he jumped on the bandwagon on a Saturday because I had to move furniture and stuff. I'm like, he called me up. I'm like, what's Nick calling me up for? And he told me I was mesmerized. So understand, if that 8-volt power supply, if it's feeding 3-wire, all right, if that shorts out, you're going to have problems. No start, inoperative computer, no communication, it's going to go down. It's like if I step on your heart, you're still alive, you're just like, oh. So you're breathing a little less, and you're going to go to sleep for a little bit. You'll be okay until the pressure is removed. 5-volt reference, that's an 8-volt power feed for Hall effect sensors. Same thing goes with the 5-volt reference that will send out to like a TPS, a map sensor, EVP. In fact, that was the 5-volt reference in that dash that went out. So 5-volt reference, which are on shareware, and an 8-volt reference feed, which is on a shareware, very critical. If they short out, you're going to have a problem. Then you have a dedicated 5-volt reference on a 2-wire sensor. Computer doesn't care. If you get a coolant sensor, 5-volt reference line, it shorts the ground, computers are like, so what? I'll put the coolant fan on. It has to. There's a strategy behind each. It'll set a code for a shorted coolant sensor, but it'll still be alive. So it's the 3-wire guide that you got to worry about. So it'll send out 5-volt reference for your 2-wire sensors, 5-volt reference for 3-wire sensors, 8-volt reference for power feed, and I'll tell you what, you don't want to sit there with a test light and go, well, let me measure that, let's see if it puts on a test light that 8-volt feed. It's not. And then if you go to the positive side of the battery and start saying, well, which one is the ground? And you hit that 8-volt reference feed with a test light, you can say, bye-bye. I've already had quite a few of them. Get calls. Yeah, I was testing the coolant fan circuit, and I was seeing if it was grounding the coolant fan. I'm like, dude, you just took a 12-volt test light. You touched the coolant sensor 5-volt. Computer's gone. It was on a Chrysler. It was gone. Dead. Wouldn't come back alive. So when you're testing reference voltage, be very careful. Just use a voltmeter. Don't use a test light. If you're testing reference ground, you can use a test light, but you can put 12 volts. It's not going to hurt nothing. It's a reference line. I've never heard one of them. It will light your test light. It's just a clean ground, because sensors have to get clean grounds. You don't want to run a battery ground to a sensor. Let's say it's busted from the sensor to the computer, because I did it once already, and it was a big mistake. I ran a regular ground from the battery to that sensor. I'm like, it's broken somewhere. I should have branched off another reference ground that was good and tied in, because what happened was this car started racing at times, running real erratic, surging idle, because the TPS wasn't clean. It wasn't clean. It kept losing throttle percent. The TPS has to learn when you turn the key on. Let's say it's at 0.5 volts, and you made an adjustment to TPS, went to, let's say, 2% now. That idle will stay high until you cycle the key to reset it back to 0%. But if you have a bad ground, it can elevate on its own, and then once it goes up to 2% while it's running, you can't get the idle down until you shut the key off again. So shielding reference grounds are very important. They're clean grounds, not the same as a battery ground. So these are the main guys. And you also have shielded grounds, which will go out and they'll shield like dynamic sensors, such as a knock sensor or a crank sensor that's 2-wire, where there's AC involved. Do you know why they twist the wires on an AC signal? I mean, does it look cute, like when I braid my daughter's hair and I try to do it? Well, why do they braid the AC lines? Why would they braid them? Noise. So you braid the line to dissipate the noise, or you can run a ground shield along that wire. You can put a metal sheath on that wire. The whole idea is you want to pull noise away from that wire. So that's why they'll shield them back into the ECM. They'll dissipate the noise. So these are the main guys, and there's one more other one. that you're going to see in these slides to come. Anybody know what bias voltage is? What's bias voltage? Computer will send it out. It's testing the circuit. It's the most powerful tool. It's just as good as using a scan tool. It's another tool in your arsenal. The computer will send out 5 volts. It could be momentarily. It could be a constant 5 volt. It could be a pattern to it. It could be like a pattern like this. Then it comes off and stops. It could be a square wave. It could be a double square. We don't know. Every manufacturer does it different. But the whole idea is to send the voltage down the line to see if that sucker is open or shorted. If you get a code that says open or shorted, it's using bias voltage. So why would we want to go in and go to the computer and measure that wire out? You ever get those tests that says, all right, unplug the computer, ohm out the wire from here to here. If you know it's running bias voltage, just go to the sensor and see if there's voltage there. If there is, that's bias voltage. That wire is not open. And if you have another sensor that's identical to it, read what the good bias voltage looks like and compare it. So this one has 5 volts and steady, like an ABS sensor. Go to the other side, if it's 5 volts and steady, there's nothing wrong with that wire. All right? And you can do something else too. You could short the wire and make it go the opposite way. If it's an open circuit, it sets a code for an open circuit, short it. If it goes short circuit, the wires are intact. Those 2 wires are intact. Because it's going to send a ground and bias voltage down like an AC line to test it for a crank sensor or an AC sensor. And you're going to see as we go along these different case studies what they do. So let's go to the first one. A 2000 Ford Ranger 3-liter, no start, no spark, no communication. I have you know that this car came from another shop that just did a head, they did a head gasket, and they must have done something with the head too, because it was pretty clean. So the guy came in, engine wasn't running too good, they put a head on it, they get done, now it won't run. And that kind of hurts, because the guy drove it in, and now you push it out. Drive it in, push it out. And he didn't know what to do with it. So his buddy down the street took the job over to help him out. And what he saw, when I went there, he saw this theft light flashing. Get used to this, guys. That's the new era. Theft lights, you're going to see a lot of them now. Some manufacturers will use a little red LED. They could put it in the air conditioning control head. You'll just see a little red LED in there. It may not even say security on it, because that's what Mercedes does. They put a little red LED right by the climatic control panel. Nissan may put a little red LED on top of the dash. They'll flash in your face. Ford may do it. Some may put it on the dash and just say theft, like these guys do. So you need to be aware of that red light. When you turn the key on, it should go on and it should go off. If it stays on, it may cut out spark. It may cut out injectors. Or it may not even crank. I had a guy who goes, man, I had a car come in here, it wouldn't crank, so I bypassed the starter. Now it cranks, but it starts and dies, starts and dies. I'm like, dude, is there like a red light flashing? Yeah. Dude, you should know that now they have these systems. Don't go bypass the starter circuits. He just put a little push button switch to help the guy out temporarily. But the car still wouldn't start because he didn't understand the system. He didn't see the light. He didn't see the light. So I think he should be here tonight, but he won't. Because he tells me, oh, you know, a couple more years I'll be out of this business. What are you going to do? You're going to sell hot dogs? So some guys just don't want to learn. And you can't force them to learn. That's why I appreciate all you guys being here tonight, because that's what you want to do, you want to learn. So this theft light is flashing on the dash. So he said, you know what? I can't do the Ford anti-theft system, so just come down here and find out what's wrong with the theft system. Maybe the keys screwed up. I don't know. I'm going to educate you on how the Ford systems work. They have a key. And in the key, there's a mobilizer chip. When they stick it in the ignition, there is a transceiver that will read that chip, send that signal to, it could go 3 different places. Ford said, well, let's send it to the PATS module. So the PATS module reads it and goes to the PCM, hey, start the car. So it's like a 2-man show, right? So they said, you know what? And then also they'll go, hey, flash the light. So actually it's a 3-man show. Then they decided, you know what? Let's cut that guy out. Let's make the instrument cluster in charge. So now you stick the key in, the instrument cluster reads the key and goes, all right, puts the light on, then puts it off, and goes, hey, PCM, start the car. 2-man show. Then Ford said, you know what? We have a better idea. Let's put everything in the PCM. There's a bright idea. So So now they put the PATS system inside the PCM. So you got to know which system you have. Do you have the PATS 1, the PATS 2, the PATS 3? It's totally ridiculous. So this system here had a PATS module system. So I said to the guy, you know what? You have a scan tool. I mean, go in there and see how many different controls in there. I know that his scan tool can get into the PATS module. He would have seen in there that said, no communication with the PCM. I know he would have seen that, but he didn't try. Just take the effort that if you see a problem with a supposed theft system, you got to find out who's in charge and see who's complaining. And that's how you nail it. And there's a lot of the Fords where I've seen the wires break on these transceivers. Where I'll go in the PATS module, it says transceiver error. Didn't say PCM error because it can't read the key. And these keys usually you have to have two. All right? And then when you learn these keys, it wants to see two different keys. Because I had one guy go, I got two brand new keys. Yeah, you did? Oh yeah, they're two brand new ones. What he did was he took one key he had and went to like Home Depot or something and he cloned another key. The guy cloned it from him. That's not the way you make a new key. You have to go to Ford and get a whole different key, not a clone key, because they sell clone keys and they sell keys with IDs. The computer's looking for keys with IDs. So if you buy a clone key, let's say this ID is, I don't know, 12. You go to this guy over here and he goes, all right, put them in. He clones them. You have two 12s. So you go back to the computer's saying, those are two 12s. Where's number 13? Where's number 14? So understand, when you buy a key, you better make sure it's not a clone key. When you're dealing with security system, you need, like Ford needs two keys. So does Honda and Acura. Some of these cars won't start unless they see two keys if you're going through a reprogramming process. So I go into there and the PATS module says, hey man, I can't talk to the PCM. All right, I go into the ECM, I have no communication. Now I can tell you on any computer, I don't care what it is, because I have one today. Guy goes, oh, the airbag light's on. All right, I went in there. It was a Jaguar, I think it was an 03 Jaguar. I went in, no communication. I could have said, let's replace the computer. But I didn't. I said, you know what? Let's check the powers and grounds to that computer. Let's keep it simple. Powers and grounds. Now, we can do an extremity check without ripping the whole console out, because I know that it's going to get, it may have battery feed. I don't know. It may have ignition feed. So ignition, battery feed to power it up. This car only had two feeds. It had an ignition feed and it had a ground. So I'm like, you know what? The ignition feed is off fuse number 10, because I had a pull diagram. And guess what? The 10 amp fuse was blown. How did it blow? I don't know. Maybe when it got into an accident, maybe the controller popped it, because it only feeds the controller. Or maybe the wire got severed. Understand, when you put a fuse in, you're married to the car. So you know what? I put a fuse in, okay, we found open circuit. If there's any problems, call me, but keep it local. Because you don't know what blew that fuse. You're praying, you're hoping, you go to church, you go, Father, Son, Holy Spirit, I hope that fuse don't blow, and that car just did about a week ago, and you'll be all right. But understand that when you put a fuse in, there's a reason why it blew. All right, just keep that in the back of your head. So we need to go in here and check the load powers ground. This guy here, when he hooked up, he had no communication also. So I said, you know what? What's the simplest way that I can check if the computer's dead or alive? I turn the key on. What is the computer supposed to send out? What? Heartbeat. What? 5-volt reference. It's so easy to do. I'll go to a lot of cars that won't start if I know it has full control of spark or fuel pulse, whatever have you, and it has no communication. The simplest place to go is a coolant, because all cars are going to have coolant sensors, right? Go to coolant sensor or go to the TPS. There's 3 wires there. One's going to be 5-volt reference and one is going to be reference ground, right? Because they're coming from the PCM, out of the PCM. You turn the key on, the computer has to turn on the 5-volt regulator and regulate 5 volts from its ground. So if it takes its ground and goes, all right, 5 volts, here you go. That's the 5-volt reference on this Ford, which is the brown and white wire. How many volts I have there? 11.45 volts. How can it be 11.45 volts? Remember, when volts are low, what should you be looking at? What feeds should you be looking at? Power feeds. When volts are high, what should you be looking at? Now look, I'm a 5-volt regulator. Now I'm up about 9 volts. I'm still a 5-volt regulator. What's happened to me? Where'd I go? I elevated myself about 4 volts off the ground. So I can tell you that if you're 5 volts at 6 volts, you're 1 volt off of ground. Or you could have a bad regulator. Could be a bad ECM with a bad regulator, but I'm not going to take a chance saying, let's go try an ECM. I'm going to check the grounds. So here's the key thing. If reference voltage is high, look for a ground problem. If reference voltage is low, look for a power feed problem. Or what else can make voltage low? What? What am I doing? What am I doing to that 5 volts? Grounding it. So it could be partially grounded. Partially or fully, I don't know, depending on what. So when reference voltage is low, you're looking for a partial short of ground or not enough power feed in. All right? So understand that. So now, who's in the neighborhood next to him going, pick me, pick me, pick me? Right next door, look. 3-wire sensor. Who do I go next? Who do I go next to? Reference ground. That little gray wire with the red stripe going through it. Because Ford's been using that for the longest time. So now I go to it. I got 11.74 volts. I got, this chair ain't high enough, but I got almost 12 volts. That's like no ground coming out of ECM. Some areas say, well, the ECM's no good. It's not supplying the ground to that sensor. Toss it. What would you do next? The ground coming out to that sensor is no good. What's that? Ground going in. Crap in, crap out. Remember that. So you're going to have to go to the ECM. Everybody's right there. Look. We'll go to ECM going, hey, look at this. All the grounds are hanging out together. Look. And they're all spliced in together. So I'm going to go right to the horse's mouth. Checking all the grounds. And look at that. 11.74 volts. There's no ground there. Look. All the guys are like this. Hey, guys. He's hooked up to the negative side of the battery. Let's go to the ECM because we found a path. They can't go the other way. They all went to my meter. Every one of them. Every one. So I'm like, all right. So now you have to go into Mitchell or all data. You're going to have to find out where does that ground reside. Is it on the battery? Is it on a fender well? Is it on the engine? I have no idea. So now I go into my data information and I find that it's on the left fender area. I check it and it's good. So now just draw a mental picture. Well, it starts here. It ends there. Got to be something in between. And just spend a few minutes to, I mean, all right, if you want, you can be, you don't want to put the cape on, be a hero and go, all right, I don't want to be a hero. But spend like 10 minutes to be a hero. You can just jump it out, put a new wire, and the car will start. But spend a few minutes, because I'm going to tell you why. You don't know whether or not that wire went through. Like today, I went to a body shop, and there was just a code for the crash sensor. And I'll tell you, one of the best tools I own is a power probe with that new screen. Most powerful tool you will ever own. If you don't have it, I'm not a salesperson. I'm just here to tell you what I use it for now. And I found out by accident how it works. It's the only voltmeter I've ever seen in my entire career that doesn't read nothing until you touch something. The screen is blank. All other voltmeters, I turn this on. High voltmeter, wake up. What's on there? Zeros. If you have the power probe in your hand and you have it hooked up, it reads nothing. So I went to the sensor because I know on airbag systems, computers have, and I got news for you, airbag systems are the most critical systems that they have to put bias voltage on everything. Why? Why? What does an airbag system doing that none of the other ones are doing? Lifesaver. Number one lifesaver. Then ABS, the second lifesaver. Not really, because I was in my Corvette coming back from Connecticut. It was raining so bad, I had wheel hop. I'm like, oh my God, I couldn't control it. I had to turn the traction control off. Scared the hell out of me. That thing was going to kill me. But I'm just telling you that airbag systems have been far advanced than any other system on the car because they've been checking bias voltage in every circuit. So bottom line is, lost my train of thought, that bias voltage is critical. And on this computer here, right, we have our grounds, 11.74. So I'm looking to see where this is going. And on that other sensor, when I checked it, there was no bias voltage. I said, dude, this wire's busted. How do you know? Because my meter doesn't show nothing. There's nothing on the screen. I know both of these wires are broken. So then what we did was I just visually saw, I'm like, all right, the wire goes down there, through there, up here, around there, because I followed the harness. So I went to the middle of the road, because I'm at the beginning of the road. I went to the middle of the road. I opened up the harness, found it, and I got a reading here. Same wire. So then I'm looking at the bend, and I just grabbed the wire and pulled on it. I pulled out 5 broken wires inside a conduit. When that car got whacked, it severed the wires, came back, and the conduit's going, nothing happened, nothing happened. But inside they're going, help me, we're all open circuit. You know, it's unbelievable what can happen. So that's why I say, take time out to look for the open circuit, because you may find other buddies with the same problem. You just don't know. So looking around, right? Look at my path. I'm like, ooh, look, there's the middle of the road. Let me go there, because I'll know whether to go this way or that way. But can somebody see what's going on here? Who can pick out what's going on there? Bolt connector. Somebody see something wrong? Who? What? Oh, someone said it first. Who? What? Very good. Where's the ground? The main ECM ground here? What's that color? What's that color? This guy better not go to Atlantic City, because it's 4 shots. He didn't even look, he didn't even index it. I mean, it can go in 4 different ways. And then once he put it in, he just hit the bolt, put it on. And there's a tab, but it goes in 4 different ways. I'm like, I felt bad for this dude. It was a 4-shot deal. And he didn't know. It was not idiot-proof. It wasn't made like a triangle. Even if it was made of a triangle, it'll screw you up. But they should have put an outside piece on it so it can only go in one way. It was not made idiot-proof. So I'm like, yay, I found it. So I pull it out, put it back the way it is, okay? And I go to the 5-volt reference. My grounds are fixed now. The grounds are perfect. I'm happy. But the car still won't start. So it won't start. The grounds are good. Now I go back to 5-volt reference again. Now I got to start all over again. Start the process all over again. Right? Because the whole thing about when you're fixing cars, you have to check, find a problem, and recheck again. Because let's say you put a part in the car. Check it again. There's no guarantee saying that part you bought is any good. I find bad parts every single week. So it's test and retest. So I retest it. My reference voltage is at 0.17. Key on. Battery feed good. Ignition feed good. So what's your next move? Replace the computer? What's your next move? 0.17 on the 5-volt reference. What would you do? Remember I said when volts are low?
Open the circuit, make sure it's not pulled down.
Very good. But the first thing you would do is get a wiring diagram through your information system, which you have to get, and see who's plugged in. Crank sensor, unplugged it. Cam sensor, you unplug it. Whoever's on that circuit. This one here, TPS, map sensor, EGR, back pressure sensor. And I'm thinking, oh, maybe it's EGR back pressure sensor, because they do melt. And it's convenient for the 5-volts to go, hey, reference ground, how you doing? Come on over here. Bink, shorts them together, done. And the computer's going, take it off, take it off. So I just said, you know what? They put a head on it. They could have crimped that wire, so I cut it. I had no choice. I had to cut it. Let the guy solder it when I'm done, but I had to cut it. Right? 0.17. So what happened? Computer went bye-bye, because that connector was put in wrong. So I said, dude, I found your problem, but I have bad news. Your computer's no good. It didn't survive. It just did not survive. So wasn't it nice how I used that 5-volt reference as a tool to just, without getting too crazy, 5-volt reference and ground checks, just using a meter. And by the way, try and use a graphing meter, because a regular voltmeter with just digits is an injustice, because it really doesn't give you the real picture. Do you know that if you had a bad regular, let's say the 5-volt regular is bad, and it's going 3.5, 3.5, 3.5, you'll get an average of 4 volts. You'll see 4 volts. I'll say this, yada, 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 yada. You're going to just see 4 volts. You want to do everything visually. That's the way you're going to learn. Where's that guy sticking? If he drops for a second, you're not going to see that if you don't have it on a graph. I mean, you look at the meter, what was that? Because look, I'll prove it. Look. You know what aliasing is? Watch this. You see it? It's straight, right? Look. What is it now? Is it rubber? Why is that? Look, I'll do it to you. Why is that? Why is that? Because the human eye can't update fast enough. So you're going to look at numbers change like this? It ain't going to happen. The human eye can't update fast enough to look at something change. That's why you graph stuff. So, and those Vantages are real cheap. I've been using this for years. I'm not here to promote it. I'm telling you I use it. I've used it for years. They're cheap now. Guys have been just giving them away on trade-ins. Give them to me. They're like $200. I paid like $900 for this when it first came out. Now like $200. They're great tools. They're graphing meters. Graphing meter, and has a built-in amp meter. It's a nice little gadget. So here we are, this poor guy. That thing's toast. And here's something else I learned the other day. Chrysler vehicle, no spark, no fuel pulse, no communication. After the guy put a transmission in. Used transmission. Puts it in, car don't start no more. So he changed the crank sensor, the cam sensor, the computer. You know what I did when I went there? What's the first thing that I checked when I turned the key on? The simplest thing, I just told you. I checked the file reference. It was gone. Computer is like dormant. I checked the able reference, and it's gone. It's like near 0 volts. I'm like, you know what, dude? Let me start disconnecting stuff that's on that. I could have cut the wire, but I'm like, let me just cut stuff. I don't want to cut now. Let me just start disconnecting the extremities. I disconnected the coolant sensor, the cam sensor, and I disconnected the crank sensor. Then I disconnected the vehicle speed sensors on the same circuit. I disconnected it, and I saw change. And I'm like, whoa, what's going on here? And what it did was, it didn't go back to 8 volts. It went back to 1.8 volts. Why is it going? So do I have another guy that's having a problem? I know if I unplugged the other two, it didn't do nothing. But I unplugged the third guy, and there was change. That's what it's all about, right? Obama says it's all about change. There was change happening there. But I didn't understand the 1.8. I didn't know what's up with that. So, okay, so I found that, and I'm thinking, I shut the key off, and I don't know what happened. I turned it back on, I had 8 volts. I'm like, where did that come from? And then I did it again, right? By the way, when I did that and I had the 8 volts, the car started up. I'm like, dude, what a chance of getting a used transmission with a shorted speed sensor. I'm like, dude, you got to go to church. That's bad, bad luck. I mean, you have to go back to where the problem started. Car ran before the trans was put in. Car didn't run after the trans was put in. It may be coincidental, but it happened. So something went wrong in that job. So I want to learn, why was it 1.88, and why was it when I turned the key off, it went back to 8 volts? And look what I did. I unplugged the sensor and I waited I'm graphing now. Graphing because I want to see visual stuff because I'm a visual dude. I'm graphing it for 10 seconds. I'm at 8 volts. I plug the sensor back in. I'm doing everything 10 seconds because I'm going to show you what's happening in the transition of time. 10 seconds. I plug it in. I unplug it. It goes to 1.88. Stayed there. Shut the key off. Why is it still 1.88 for 10 seconds after I shut the key off? And then drop to 0 when I shut the key off. Wait, watch me. Going to sleep. It's going to sleep. It's probably looking like this a little bit. All right, let me go to sleep right now. All right. But that one took 10 minutes to go to sleep. 10 seconds to go to sleep. Then when I turned the key back on, went back to 8 volts. Even though I alleviated the short, it did not go back to 8 volts. And I know why. I caught the bad wolf there, the scared little wolf there like this is going, is he gone? Is he gone? Let me go to sleep and everything will be okay. Is he gone? 1.88, that's all I'm going to give you. Goes to sleep, wakes up, the big bad wolf is gone. So the bottom line here is, if you're checking a reference voltage, reference power, and you believe it's shorted and you alleviate it, you better shut the key off and put it to sleep. Because there is a time period before it'll come back. Because that may be the way the computer's protecting itself. It sees a dead short and it doesn't want to ruin the voltage regulator within that ECM. So I did that so I can learn from it, because I had no idea. I always thought if you unplug it, it goes back to 8 volts. It does not. It does not. But what you want to worry about is change. That's what it's all about. Here's our 2002 Ford Escape. And you see how important, that's why I went over all these voltages in the beginning, because they're all going to fall into place on every car. It's what helps you diagnose the cars, is the foundation. You know,
what became of that, you were talking about X-ray sensor on the other car?
Oh, well, he had severed wires. The wires were severed. So I'm like, dude, you're on your own. You got to fix like 8 wires. That's it. I'm out of here. But you know what? On that car, luckily, it'll reset itself. I can tell you on Ford, GM, and Chrysler, when there's a problem, the light's on. When you fix it, the light goes off automatically. There is no reset. A lot of other manufacturers should follow suit and go, well, there's a good idea, because after he fixes the car, the light should go off. But they don't do it. Honda just started doing it on 06 and up vehicles. That if the problem is not there, the light will go off by itself and go, They'll look around, go, hey, how you doing? Everyone's okay. And the light will go off. But some manufacturers don't do it. But eventually they all will, if they're smart. Here's an airbag light on a 2002 Ford Escape. That's the complaint, airbag light on. Hook up the scanner, and it says, right front seatbelt potential circuit open. How does it know? What's it using? All right, nothing to is, a lot of the components, pretensioners, clock springs, airbag units, if you ever took a connector off, you ever notice on the two pins, there's these two little bars? What are those bars for? Shorting bar. For what? What are they, just to say how you doing? Every time you pull a connector off? God damn. Hear what he said? It'll dissipate. Because if you pull it off, and God forbid you create some type of energy there, or if there's energy there, it could pop. So when you pull the connector off, the shorting bar will latch and short out the two pins. All right, so nothing's going to happen. And then when you put it back in, on the newer connectors, well, on the older connectors, it'll just push the two bars away to make a connection. That's what they do. But on the newer cars, now they're doing something else. They have a lock. So you have to pull the lock out. The lock, when you push the lock in, when you push the lock in, you push the connector on, all right, those two bars are still shorted. They're still shorted, the two bars. Until you push this little lock in, then it pushes the bars down, plastic lock. So some guys will go like this, I can't get this stupid thing off because the old ones used to pull off, bink, and they break the lock. I'm like, dude, there's been changes that are happening here now. Used to be you used to pull it off. Now you have to pull the lock out, then pull it off. You don't just yank on it. Now you broke the lock. What do I do now? Where are you going to buy an end from? Because you go to a dealer and go, you need a whole new harness, $2,000. You out of your mind? So you have to buy a new end, and you have to solder it. So that's why they have the lock. Now here's the good thing about the lock that I've learned through diagnostics. Let's say I have it in place, and it says airbag open circuit. If I just pop the lock out, what should happen now for the code? Airbag short circuit. Isn't that cool? I can pop the lock out, check the scanner again, and go, ain't the wire. There's maybe something wrong with this component, like the seatbelt, because now seatbelts, you get a seatbelt. Used to be that old grandma is in her car, and she's driving along, bam, she hits a deer. Deer jumps out, and old grandma killed Santa's deer, right? And all of a sudden, boom, pulls her in. She goes, help, I hit a deer, and I can't get out. They actually hold. They don't release. You have to have a guy come along and just cut the seatbelt. You can't pull it out because they're stuck in the seat. Now what they're doing is, because you know, if you sew and deploy, you're like, all right, this belt's taut, it's no good. Or here's the other one. It'll pull you in, then relax and drop. All right, so now you look at it, it's stuck out. It ain't going back in. So if it's taut or it's hanging, it's no good. Now, when they deploy, they still work. So I guess if you get a minor hit, you can say, hey, I'm okay. The belt loosened up, it still works. You latch it in, you go. You still have a belt. But the problem with that is now, you don't even know if the belt's good or bad anymore. Because I used to do visual inspections and know they're bad. Now, I'll get a Honda like I did today, and it said, okay, I probably, this is no lie, they'll have a code that says, I probably deployed the airbag, the seatbelt, and or the buckle. So, but which one's bad? It doesn't tell you which one's bad. So I go, well, the airbag didn't deploy. The buckle deployed, it sucked down, but I wonder if the belt deployed. You don't know. So you have to physically go there and do an inspection on it and ohm it out. Because mechanically it still works, but electrically it's open circuit because there's like a little gunshot shell in there. So understand what they're doing with these belts. So here we have open circuit, it's checked by bias voltage. And I'll tell you one thing right now. You look at an ABS sensor, and if he's off a half an ohm, he's like, I got 1,200 ohms. You think I care about 1,200? If I'm at 1,195, you think I care about, 1,199.5, I don't care about a half of ohm drop? On an airbag system, if you're off by a half a ohm, it'll set a light. Immediately set a light. Half a ohm. Does anybody know the resistance of a clock spring? What do you think it is? It's about a half a ohm. That's it. And you can check the airbags from side to side in the front. This side will be 2 ohms for a passenger airbag. This guy will be 2.5 because of the clock spring. And you go get another set of airbags used, they better be 2 ohms and 2.5. I had a guy buy one for another Taurus used, and they made some kind of a change. They went to like 1 ohm, at 1.5 and 1 ohm. The connectors fit, but the resistance value was off. And it drove me crazy. I'm like, dude, I don't know, but it seems like maybe the airbags were, no, I got that. It was 1 year off, and they made a change. They went to a higher reading. So that half ohm means a lot. So let's go in, let's check it. Here's the bias voltage.
Put your ohm meter across those 2 pins on an airbag?
Yes, you can. You can measure it there, but you know what? The best way to do it is at the horse's mouth, because you're doing an injustice. Because number one, you unplugged it. No, you unplugged it, right? You want to check the whole circuit. You want to ohm out the whole circuit from the computer, because you never know. I had a Mercedes kick my butt where the 2 wires went to a connector under the carpet, then jumped from there to the airbag, and I didn't realize there was another connector in between. Who would put a connector underneath the carpet? It's beyond me. I didn't know. But if you go and just unplug the connector, let's just say for testing purposes, look what it's doing. It's going up, down, and over here, a little goober. And it's doing this is 1/10 of a second. 1, 2, 3, 4. So it's testing it every 1/10 of a second. It's sending bias voltage continuously. So it's looking for change. All right, so let's just say, and look at this. 19 volts, look, it comes down. For what reason, I don't know. That's what they wanted to do, the engineers. It goes up to 19 volts, comes down across, a little goober, and it's done. That's in 1/10 of a second. Where's 19 volts come from? Battery? 19 volts? What do you think is inside that little airbag control unit? It's got to be some kind of hefty inverter, because it's sending out high voltage. It doesn't want to use low voltage. So understand that if it's unplugged, that's what it looks like. Once you plug it in, it's going to change. So it knows, it can tell by current and the voltage what the ohms are. It calculates the ohms. So I want you to see what kind of pattern that is. That's just on one car. They're all different. And then when you check that pattern, here's the connector. Here's the tab. I just put my negative lead here and my positive lead here. Now that's the guy on the right side, right? Because he has a problem, and I don't even know what the bias voltage should be. I'm looking at him like, all right, there's a little pattern there. I don't know, is that good? Is it bad? I don't know. And the other side, the guy's going, pick me, donor, check me out. So I go to the other side. I do the same test. Should I keep my leads the same way on that connector? Does it matter which way I put my leads? Well, yes, it does. Because they're biased to one direction to go in crash sensors. Seatbelts and airbags, not so bad. When you deal with crash sensors, that's why I always test the same way in the connector. Hold the connector, test the same way. Go to the other side. Because I had a guy one time, crash sensor code. Brand new crash sensor, you ohm out the harness again. You go by book says, disconnect the processor and measure the wire from point A to point B, point A to point B, and if everything's good, change the computer. Well, that's a real good test. Because you know what? That's what he did. He changed the computer, and the crash sensor code's still there. Dealer says, need a new harness. For what reason? And what had happened was the car got hit, severed the crash sensor wires, because I had to do a little interrogation. The guy repaired the wires. They're both brown. I'm like, dude, how did you know which one where? He goes, well, they're both brown. But they're dedicated to go in one direction. He doesn't know, so I educate him. Because I didn't know, I had to learn as I went. So understand that you get a crash sensor, those wires are dedicated. You get a new ABS sensor, the new style ones, that you can't ohm no more, because the old ones, you used to be able to ohm them, and you get a resistance reading of 500 to 1200 ohms, like the old days, old pickup coils. The newer style the crank sensors that are magnetic. They just have a field coil, and they produce AC signal. The new ones don't. They produce a square wave. It's a 2-wire square. It's called magnetic resistive sensor. The polarity, it has to be in one direction. You swap those wires around, you will get an ABS code. You will, and the ABS sensor won't work. So understand, when you're testing wires, you test the good. You better hold your leads in the same way and test the other side. And books won't tell you that. Their books just tell you how to check the wire, and they're not going to tell you all this other good stuff about bias voltage and reverse polarity on these signal lines. Ain't going to happen. So bias voltage is a good friend. Now look, the computer said the potentiometer on the passenger side is 4.9 ohms. The driver's side is 2.7 ohms. Is that a problem? Is that more than a half ohm difference? Yeah, it is. It don't like it. But it said open circuit. Why didn't it say high resistance or minute resistance? It says open circuit. So understand when you have an open circuit, it doesn't necessarily mean the wire is open circuit. It can also mean high resistance. Just so you understand that. And these are the potentials that they use. They're all different styles, but the main thing is to look at the bellows. Because when they fire, they contract. They pull all the way down. So you can do visuals and go, well, this one's sucked down, this one's still up, so this one must have deployed. But like today, I had a code for a seatbelt potentiometer, nothing wrong with it. And this is what I found. If you notice the connector for these seatbelt retractors, they put them underneath the seat. That's where they all are. That's just where they live. But what also lives underneath the seat? Everything else. Water bottles, you name it, moisture, guys washing your carpets, doing you a favor, right? That connector can be exposed to moisture. And even a half an ohm difference can create a problem. If it's an electric seat goes, I got a little moisture on me, who cares? I got enough amperage. You think I care? Half a ohm? Airbag won't tolerate it. So here's the magic stuff. Stable 22 has fixed many airbag lights for me. I go in there like, I put 2 drops on the connector, and I'm like, yay! It's very powerful stuff. It's made in Canada. It's called SL5 through standard ignition, and all you need is a little drop on a connector. And it will actually, when electricity flows through it, it becomes conductive. It actually makes the wire conductive and creates a better connection. And I'm going to show you how it does it. And then when you store it, put it in a safe place. And do not use it on battery cables. It's made for computer terminals if you want a better connection. And if you're going to store it in a cabinet, don't put it next to the eye drops. Because if a guy gets something in his eye, he grabs a stapling, he's in big trouble. That stuff will put your eye out. So I'm just telling you, watch where you store it. Stapling 22A. That stuff is almost $50 a bottle. $50 a bottle. Keep it around if you have bad computer connections. Even if you have, like, let's say, Radio Shack carries it, they call it tweak. Same stuff. They probably charge you more for it, I don't know. But it's called tweak, it's for speaker noise. Just to show you what I did here, look, before and after. I'm measuring on the scanner, graphing, because why? Visual. You can graph it, right? I graphed it here. And look what I did over here. What do you think? Look, it's at 4.9 ohms. What do you think I did over here? Well, did a wiggle test. Been around for many years, right? Did a little wiggle, wiggle, wiggle. I'm like, wow, look at that. This is cool. But did it correct itself by wiggling it? It may, temporarily. You go, yeah, I wiggled and the light went out. All right, let me charge the guy. He'll go around the block, he'll come right back. Because you didn't do nothing but wiggle it, right? Then what I did was I unplugged it, and notice from here to here is 10 seconds. Within 10 seconds, I unplugged it, put the JISM on there, closed it up, and I'm doing good, but then I wasn't satisfied. I pulled it apart again, and you can see I was nervous right here because I was graphing. I couldn't get the connector just in right. I'm like all nervous and stuff. So it took me 10 seconds for me to put it back together again. But look how clean it is. Look at the end result. It's clean. It's fixed forever. I'm telling you. They're always all fixed. They always are all fixed. I see this problem with Fords, a lot of Asian cars, with people who are just slobs, and then they'll blame the light on the accident. Well, I never had the light on before. Maybe there's a reason why your airbags didn't go off, because that problem was there before. See, deployment happens when the system's working. If the system doesn't work and you get into an accident, I see like bad accidents, I'm like, nothing deployed. Maybe the light was on before, and that's what happened today. I'm like, dude, it's a connection problem. What do I do? I said, I don't know. Problem was pre-existing. Did the lady get hurt pretty bad? Because she had no marshmallows to stop her. So understand that connections. And look at this now. We're at 2.4 and 2.3. Is the computer happy here? And look at the airbag again. Driver airbag's at 2.6. Passenger airbag's at 2.1. Why is that? Shouldn't they be the same? Clock spring, half a ohm. Very good. Very good. So half a ohm. That's all it'll tolerate. Right? So, because it's a very, very It's a very touchy system. It's liability issues. So I learned a lot of stuff from airbag systems. They've taught me about using bias voltage is the key thing. That is the key to diagnostics, bias voltage. 2001 Chrysler Town & Country, no AC. Now I got news for you, AC has come a long way. It used to be that you hit the switch, and then the switch took a ground, went to a pressure sensor, and if everything was happy with the AC pressure, then that wire continued on to the relay, and ground the relay contacts closed, compressor came on, everybody's happy. It was like a chain reaction, bink, 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 but it changed now. Now, computers are in charge. A lot of strategies going on, a lot of strategies, a lot of sensor inputs, and it will decide whether or not it wants to put the AC compressor on, whether it wants to do it or not. So you have to understand how that system works. So it's the inputs, you're the command, you're commanding it on, that's the command to go in, then it has to look at all sensor values, and it will decide what it wants to do depending on what type of sensors are controlling it for the final output. So I just took a basic OBD2 generic scan tool, just to scan for codes, see if anything's going on. I mean, I could get my factory enhanced tool or factory tool to go in by year, make, model, you know, Chrysler, whatever, year, make, model, and go in that way, or I could just go in generically, and I just put in there, no codes. There's no codes. And then I'm like, all right, let me go a little step further. I'll look at some PIDs, see what's available in a generic mode, generic OBD2 mode, okay? Because understand, when you're doing enhanced work, watch out for this. If you want to just do checking fuel trims, drivability problems, checking mass airflow, so it's good. But when you're doing enhanced stuff, I want to show you how you're going to have to be careful. You're checking here, right? You have your coolant sensor, your map sensor, your TPS. Now, what sensors do you know that would contribute to not putting the AC on? Just give me some ideas. What? Outside air temp? Yep. Outside air temp? Throttle position. If you have wide open throttle, you think the computer's going to say, all right, let's leave the AC on. It has to turn it off. What else could contribute to no AC? Cool power steering pressure, coolant temperature. And there's another one too that almost burned me on a Mercedes. Pretty cool. They have a, what?
Inside air temperature, heavy and air.
Well, yes, that too. But they have something else in front of the compressor.
Speed sensor.
Speed sensor. Good man. A speed sensor. Why would they put a little miniature crank sensor right by the compressor? They put a little thing that's spinning, it's reading it. Why? Belt slippage, and what else?
Compressor lockup.
Good man, good man. Compressor lockup, because if you command the compressor on, you don't see it move, are you going to leave the current there? Hell no, you pull it back. And let's say the ambient temp sensor is saying, hey, it's wintertime, don't put it on. Is it going to put on AC if it's wintertime? No. But I have news for you. Those ambient sensors, these manufacturers are putting them in the wrong spot. They put them in the front of the grill. They put it like, I don't know, in the wheel well. And if the car gets hit, they get trashed all the time. All the time they get trashed. You got to find out where they go. You got to find out if they're hooked back up. You got to figure out if they're damaged, if they're out of calibration. And without a factory-enhanced scan tool, you're not going to see that data. It's not going to be available. And even on this generic data, I didn't have air temp. I didn't have it. I don't know why on this particular year, make, model. But I had TPS. I had coolant sensor. But I want to see more stuff. I want more. I have to go on to the enhanced side. So I got to take a walk on the wild side. So here's where we go. Now we go to the wild side. You ever notice the little light that comes on when you push the AC on? Why is that? Why is that light on? You want to make sure you create a command. Because these dash panels may be sending power or may be sending ground. We don't know. But also, too, you got to watch out because the older ones went like this. Like the ECM is right here, and they'll go, he just pushed me. You're it. It's done by a wire. Now it's all done through electronics, where it's like, hey, put the AC on. He just pushed me. The light's on. Do it. That's the way it is on this car. So the confirming of the AC output is there. Okay? And it's done through a network. Here's the AC control head. Look at all these guys in the network. 1, 2, 3, 4, 5, 6, 7, 8, 9. They're all on a network. There's all different type of networks out there, so I'm not going to get into network or class, but just to let you know, he's going, hey, everybody, look at this. He just wants the AC on, so he puts a call out to the PCM and says, hey, put it on. And we don't know the strategies of all these other computers, what can happen. When the AC is commanded on, things can happen in the network that are programmed into all these other computers because they have to know the AC is being put on. And we're going to look at data on the scan tool just to show you why you need enhanced data. If you're going to do enhanced work, you need enhanced data. If you want to do a drivability problem, you can use generic scan tool. You can. There's nothing wrong with it. But there's guys who, I said, you know, if you have a generic scan tool, you have to supplement with enhanced stuff too. It's good to have both worlds. I mean, I've hooked up generic scan tools a lot just to do simple jobs. But if you're doing enhanced stuff, it ain't going to work. Not to put on an AC clutch to command it on to do functional procedures. It's not made for that. It's not made to do that. So understand that. What is... You can see here it says AC request input on. You see that? AC request, it says desired AC clutch relay off. It's off. I mean, even though you command it on, it says, well, I desire to keep it off. It's kind of like you come home to your wife and she goes, I desire you not to touch me. But I'm turned on. I'm not. I'm off. You understand how that is? So one is reality, and the other one is, I tried. Right? So, and then if you look over here, why does it say actual AC clutch relay control high? What does that mean? When a circuit, when a computer has to ground a driver circuit, before it grounds it, it's considered high. When it grounds it, it's low. So what if this said AC request input off, AC clutch relay off, but the control said low and the compressor's running all the time? What would that say to you? Why is it on? Why would that be on its own? Why do you think? A grounded relay, or someone put a little, which I saw a guy do, he put a on-off switch for the AC. He did, he controlled his own AC clutch. I didn't get a chance to write that story, that thing was wild. He even put on there, on the switch, he put off and on. I'm like, dude, that's cool. But understand why they give you that command. That is an extra information that you need. Okay? So that's one thing there. So now you're confirming the command got to the control. You don't want to say, well, let's replace the ECM. What's another thing you can do to alleviate a lot of work with your enhanced tool? What can you do to the AC clutch? What? No, but what can you do to the AC clutch? Put it on. You command it on, command it off. Yes, off, on, off, right? There it is. Desired clutch relay on, AC clutch relay control low, because it grounded it. And you can hear the clutch come on. Now, I eliminated a lot of wiring problems, because I know now the command is good, I know the computer's good, I know the relay's good, I know the clutch is working. It's all a strategy problem now. And there's no codes. There are no codes. Because I even used on the enhanced side, there were no codes. All right? Let's look at some inputs. Strategy. That's what we want, strategy. Cool temp, 217. Is that okay? Why do they have the voltage as well, 2.02 volts? Why do they show them voltage and the reading? What if the voltage was 5 volts? And we have a code for the coolant sensor high, but yet the reading is normal. What's going on with that? Why would the reading be normal if it's at 5 volts?
Substitutive value?
Substitutive value. Good man. That's why Chrysler does that. If you have a scanner, enhanced data, and they're giving you both, there's a good chance that manufacturer's using substitutive value. So don't look at the value and go, oh, 212. So it can't be a coolant sensor problem, but dude, look at the voltage. It's at 5 volts. You have a problem. If you have a code, you have a problem. Just because the temperature is good, it defaulted from another reading, maybe the air temp. I don't know. And also the fan will stay on all the time. So understand about defaulted values. If you have both those values, it has the capability of using defaulted values. And here's the air inlet temperature, which is 4 volts and 1.14, 1.1, 114 degrees. Here's the ambient / battery temp sensor, 114. What's a battery temp sensor? What is that? Battery temp sensor. What's that, inside the battery?
Usually IX.
It's around the battery. Why would the manufacturer want to put an air temp sensor around the battery?
Charging you.
Because maybe that controller is also controlling the alternator, and it wants to know, is that battery hot? Should I just charge it more to blow it up? So it's going to look at the temperature around that battery to tweak the charging rate. Understand that. Now here's another question. That's ambient temp. Which ambient temp sensor could be anywhere. Behind the grill, it could be by the air cleaner housing, whatever. But then there's idle air temp, no, intake air temp, and air temp sensor. Are they the same? Air temp sensor, intake air temp sensor. Are they the same? They're both measuring air temperature. Are they different? Wait, one more time. The acronyms, right? IAT, ATS. Air temp sensor, intake air temp. Are they the same? How are they different? Location? No, where are they located? One's in the intake, and one is by the air cleaner. So understand, there's a big difference between those two guys. Because if one's in the intake, he's going to run a little hotter. He's in there hanging out. So understand what there's a difference between those two sensors. Even though they both measure air, depends on where they're located. All right, so now we move forward. Okay? And I want to ask you a question. Where's my AC high pressure? What's that? 0. Where's the volts? 0.18. I'll have you know I know the normal reading. It's 1.7 because I saw one on the Chrysler the other day. Why is it not setting a code for low pressure? What?
The AC doesn't see the compressor on.
No, but why is the computer not setting, hey, we're low on Freon? Why is it not setting a code? It's a valid reading. It says you're out of AC. See, there's computers who can rationalize. There's other computers who don't rationalize. They're like, well, it's still within range. It ain't open. It ain't shorted. So the hell with it. Let him figure it out. And I go, dude, you sure you got Freon in here? It's fully charged. I checked it. Ah. I'm like, all right, dude. All right. I won't put no gauges on. I'll take your word for it. But it says 0 pounds. So understand that if it's in range, you don't set a code. Depends on the strategy and how smart that computer is. The newer computers will rationalize. They go, some of them will go, hey, you know, you've been driving this car for at least 25 minutes and the temperature didn't rise much. I think you got a stuck open thermostat. That's rationalizing. And that's what a lot of computers are doing today, rationalizing. So now I'm looking at the scanner and I'm seeing 0.18 volts. The sensor, we're going to go take a look how it's made because I'll ask you a few questions here. It's a 3-wire sensor. Look, it's going to get a 5-volt supply, a reference ground, a reference voltage, and it's going to send a signal back. It's a pressure transducer. Is it a map sensor pressure transducer? So it's no different. So we're going to check it out and see what's going on, right? I'm measuring 0.19 on the scanner. Is there any guarantee it's the same reading at the sensor? You're going to condemn the sensor right away? So let's put a sensor in it. Are you going to pit the scanner against what the reality is? Because I would. Because remember, it's a 3-wire sensor. There's no guarantee that third leg is making it back. With a 2-wire sensor, there's always a guarantee because if you go to the sensor, it's 5 volts in ground. They both made it there. But if you go to a 3-wire sensor, you have 5 volts in ground. They both made it there, but this little piggy may not make it back home. He's hanging out right here. So you have to go right to the sensor and let's pit it. Don't always trust the reading on the scanner. You're always pitting the reading. So I'm going to go to the sensor. I'm going to measure it for power and ground. Because remember I said if your voltage reading coming out of the sensor is low, what are you going to check? Reference power going in. Because if there's a problem with reference power going in, it's not going to have enough voltage coming out. So always look at something. If it's low, check the powers. If it's too high, check the ground going in. So I did something simple. I went across the sensor, checked the 5 volts in ground, and I'm like, wow, 5 volts. Now, if I had no reading, then I have to take this lead here, put it on ground, because what if the ground was busted? I don't know. So I'm just checking both at the same time. Then I took my red lead off. I went to the sensor output. And I got 0.12, so it's just as low as a scan tool. And I'm like, let's put a sensor in it, right? Should I put a sensor in it? Because the reading's low. What? Ooh, what? Could be pulled down by a ground. Could be. He's right. That wire could be shorted. So we want to check all this stuff. Because if it's low, it's either lack of voltage going in or a partial short to ground. So I did something here. There you go. Yeah, I trusted that guy, right? Now, I pulled it off, and a miracle happened. A miracle. I went, oh! I had to stand back. I'm like, 4.95 volts on that signal line? How did that happen? How? What? Bias voltage. So you guys are listening. That's why I discussed all this at the beginning, because let you know that I keep using it. It's bias voltage coming out of the computer. So do I know if that wire is going from the computer to the sensor? Do I know if that wire is shorted? Just by unplugging it. Now, I ask you another question. I unplug it. What do you think the scan tool is now saying? It should say low voltage because there's no signal coming back from the sensor. Open or, but look what it says. And I had to struggle with this a little bit. Code P1598. Volts too high. Do you know the computer is reading that line and the bias voltage is on the line now because it knows it's an open circuit, it's reading the bias voltage, it's saying voltage is high. It's normal. It's just a strategy of Chrysler, that's what they do. But that code wasn't in there before. Now, I go back to the OBD2 side, take a walk on the other side, and look what I got. Do I have any codes? I cleared the codes a few times, cleared them, because you can see all the monitors were set. And the code was still on the enhanced side, P1598. Why is that? I want to know. It's not a generic code. All right. I'll give you another one. Had a car today, a Hyundai. My first shop order this morning. I was very disturbed over the whole thing. He had a Hyundai 97 Hyundai's Accent and had a code for Bank 1 Sensor 2 slow operation. He had an aftermarket sensor in, didn't fix it. He put a factory sensor in, didn't fix it. When I hooked up the Hyundai factory scan tool, I had 4 codes. I had cam sensor code, PO340, PO340. Is that generic? Okay. I also had, these are all in my truck. I left them all in the truck. But the other one dealt with CAT efficiency problem. Should I worry about a CAT efficiency problem if I'm having a Bank 1 Sensor 2 problem? I wouldn't. Then I had a Bank 1 Sensor 2 problem. And then I had another one for, there was another problem in there. Oh, evap small leak. PO4 something. I had 4 codes. One was a P1 code. The other were PO codes. I tried 3 generic scan tools on that car. They all pulled 2 codes each. I was a little pissed off because I used the factory enhance and I used generic OBD2. This is not the fault of the tool. I'm here to tell you that. This is not the fault of the tool. I'm here to tell you that there's no guarantee that you hook up a generic tool that it will always pull codes. There is no guarantee. It's not the problem with the tool. I'm telling you that. And the problem is the EPA doesn't do all the checks and balances to see what's going on. That the computer may have stuff on the enhanced side that you won't see on the generic side. So I use a generic tool. I love it. I use it for diagnostics because I can look at generic stuff like I look at short terms, long terms. I use it all the time. But I now know that I always go in on the enhanced side to pull all the codes. I said, dude, you got 4 codes. So let's take it with just the 2 codes. All right? So just understand, don't get burned, that you have to watch out that when you want to pull all the codes, that it may not always pull all the codes, and it's not the tool. It's the manufacturer. So I guess as the cars get newer, they're cleaning house. That car was a 97. Obviously, its house wasn't too clean, but that was the problem. And let me tell you something. This car burned me. Bank 1, Sensor 2. Lazy operation. And you know what? I was watching the sensor, and it wasn't moving, but I snapped the throttle, it moved. And I'm like, wow, that cat must have lit up pretty quick, because here's the phone going like this, yada, 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 yada. And I snapped it again, snapped it a couple times. I said, the O2's working. I said, but that cat lit up pretty damn quick. Look at it. Cat efficiency is really good, because it's flatlined around like 170 millivolts. And I'm like, God, let me check the O2 heater circuit. Maybe it's not heating it up enough. Maybe that's why you had the problem. I checked all the wiring. I'm like this. Dude, I don't know what to tell you. It's working. And maybe I should have checked it when it was cold to see if they were mimicking each other. Because you can do that even with a generic scan tool. You watch, you just graph, when you're in generic, just graph the O2s by themselves. Because the more guys you try to look at, the slower it's going to get. You understand about generic OB2. But I put it in the generic OB2 mode, and I was graphing it, right? But this guy was level. But if I did it cold, they would have moved. And I said, you know what? That cat don't seem that hot. And I just sat there mesmerized. I said, I don't have an answer for you. And then I cheated. I'm allowed to cheat. I went on Identifix just to see. I'm like, hey, did anybody see this problem? I punched it in. And there were like 10 dudes. They all said, flex pipe. I'm like, flex pipe? Do you realize that they put this sensor right behind the flex pipe? The flex pipe cracks, and it's reading outside air, and it reads lean all the time. I'm like, oh my God. How did I miss that? Why? Because I jumped the gun. I checked it. I should have started up right away, because when you first start up, it's always low. It'll never move because it's just pulling, it's just reading outside air, it's just being sucked in. And they tell you put your hand over the pipe, and you'll hear that middle go, pull, 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 pull. It had a leak. And here's the sensor, here's the pipe. The pipe was leaking right here. I was totally mesmerized by the fact that a rear O2 sensor for slow activity can be created by an air leak in the exhaust system. Number one. Number two, the factory tool had 4 codes in it. The generic tool had 2 codes in it. So I'm here to tell you, beware. Beware. All right? I almost got burned in that car. And I said to him, dude, you better write down these other codes, because this car may come back for a cam sensor, which there may be an update for it, because I know Honda Kias have a problem with cam sensors. And then they're going to come back with eval code. And you want to know something? I have the printout. It said MIL off. Why is the light off? It didn't have a light on. It said MIL off. I'm like, dude, maybe there's someone with his computer. Because I didn't want to say, let's go buy another computer. Why did the computer not set the other 2 codes on the OB2 side? And why did it not put the light on? I had no answers for it. Tell you a question? Dude, not really. I mean, you know what? The way you have to check it is putting your hand over the pipe, because it has a little bolt on the header. But this leak was right in front of the sensor. It blew my mind. So if you ever get one of those slow operations, you better check. Check the sensor cold, not as it's warming up. Just check it cold and watch it. It has to mimic the front sensor. Reprogramming. A lot of confusion about reprogramming. A lot of confusion. And I'm here to set the stage, to let you know what it's all about. You know, you could buy a subscription. Some manufacturers say, well, you can go out and get your generic pass-through. There's a bunch out there. I'm not here to say who's best and who sucks, but you get one, you own it, and you're like, yay, I'm going to program computers. Not that easy. Because here's the thing. Every manufacturer plays a game. They're all games. And the EPA still has to clean up house. I like to have a little talk with that woman, and we can go a little further with this, because there's still issues I have that she has not resolved. We need a 1-day package. When Volvo tries to charge me for 3 days, I have an issue with that. Because I'm not paying for 3 days. I want to pay for 1 day for $30, not 3 days for $110. When I do a GM car, I have to pay for a whole year, $1,400. And that don't even include wiring diagrams. You don't get wiring diagrams with it. Or any reference material, that's another $1,200 a year. So that's up to $2,600. So Ford's nice. They give you 1 day for $30. That's cool. So they all have per day, but some have per month, some have per year. So sometimes it's cost effective to say, well, let me go to the auto store and they'll program it off board. They can do that. Taking an existing controller, and when you're programming, you're putting software in it to correct problems, to make it run better. But once you go black, you don't go back. Should have said it that way. Once you go forward, you can't go backward. And the problem with that is you can't take the new software out and put the old software back in. You can only keep going forward. You can't go backward with it. It's just not going to happen. So people go, well, now my gas mileage, it sucks now. Because I'm like, you know what? You can't have performance and gas mileage at the same time. The car might have had to go through the EPA to meet, gas mileage. And now people complain, well, I have hesitation, rough idle. So then they go, time to tweak it. So they tweak it. But you can't go back. So you can't have performance and fuel economy at the same time. It's not going to happen. So you're putting software in, no problem. But here's the problem. It's when you're going to put a new controller in, new version to the car. You're putting software in, but the games are going to change a little bit. Because there's a lot of things you need to know. You have to enter the VIN into that computer. That's called, not reprogramming, it's called reconfiguring, recoding. Because what you're doing is, you're making that computer belong in that car. You're going like this, okay? You belong in here. I'm going to put the VIN number in. So you put the VIN number in. And you better be wearing your glasses when you do it. Because if you're off by one number, and it says, are you sure? You say yes. It'll say again, are you sure? And you say yes, it's married. You can't take the VIN out. That's why if you buy certain body control modules for GM cars, you can't override the VIN. There's certain computers you can override, but there's others that you cannot. So once you put the VIN in, it's done, it's configured for that particular car. Year, make, model, wheelbase, the whole 9 yards. Then there's something called mileage entry, where certain scanners may allow you to do it, others may not, unfortunately. So I know the DRB will. It'll say SIR memory check. It goes in, it writes and reads, writes and reads. Okay, how many miles in a car? It'll say, is it 0 to 50? I'll say, no, it's 85,732 miles. I put it in. Why is that important? Why are they putting mileage in? For what reason? So you know how many miles are on the car? What? The what?
The odometer.
Nope. Why would a computer want to know how many miles are on the car?
Well, these cars, they might.
Some kind of adjustment. They can adjustment to the mileage.
Very good. Adjustment for where? So let's say you put a brand new motor in it. You could just say 0 to 50 miles. It's going to run different. It has to. It's the appetite of that motor. So I can put mileage in, and you may not be able to. I know the factory tool can, and I know there's other tools that cannot. So you can put the VIN in, but you can't put the mileage in. So understand that. So there may be features that are not in your tool because they don't have to put in the tool. There's certain things that are ripped out and left out. And we'll talk about that. There's not a guarantee everything's going to be in there. All right? But the factory tool has to guarantee it. It becomes a lot of money when you try to duplicate a factory tool. A lot of money. I have $300,000 in 22 scan tools. So you're going to buy a tool for $5,000 that's going to do everything? It can't. It's all about this. I can do 55 modules. You can do 10. It's reality. But understand that you're going to have to put mileage in. You have to put the VIN in. Vehicle options. You may have to put tire size in. All right? What is Chrysler called? Opinion factor. You may have to tell whether it's all-wheel drive or not. And then you also may have to enter codes. Like you'll get one module that's coded 1, 2, 3, 4, 5. So when you put a new module and you go 1, 2, 3, 4, 5. Prior to doing that, let's say you get an airbag module. Right? And in the module, it's not coded yet. You have a code for right rear side airbag, left rear side airbag, right front side airbag, left front side airbag, passenger airbag, driver airbag, seatbelt protection. Why do you have all these codes? Why would you have all these codes for all these components when there's nothing wrong with these components? You just put a brand new computer in it. That's not coded. It doesn't know what's in the car. So what you're doing is you're putting these numbers in to tell what is in the car. And you better know what those numbers are. Because if not, you have to fish for those numbers. You have to search around for these numbers and find out what they are. And you may not find them in all data. The dealer may not give them to you. So it's nice to have the old controller and go in and go, oh, 1, 2, 3, 4, 5. If you don't have the old controller, you'll spend some serious time trying to figure out what to put in there because you don't put them in right, it'll tell you, not coded properly. So you need the magic numbers. And you think that's easy? Try working on a Mercedes where they have string coding, where you're putting in 52-digit numbers. And you're like this, O1, O2, A1, B1, 3-1. And you get to near the end, and you're like, it says, sorry, you're wrong. Like, oh, maybe it wasn't a B1. It could have been an A1. You're off one number. You got to start all over again. That's string coding, okay? I coded one module on a Audi. I got done, and the airbag light went off, and it said, you're good, no codes. But I look, and there's an ABS light on. I'm like, was that on before? And I'm like, that light wasn't on before. Why is it on now? So I go in there, and it said, hey, man, somebody in the network ain't coded right. Yes, it is. No, it ain't. Yes, it is. I'm like, oh, my God, what do I do? And I had to go out to Massachusetts to do the first class. And I'm like, I don't do this. I never saw this before. Nick here saw already. He goes, John, he goes, there's a new thing out. I said, what do you mean? I coded. He goes, no. You have to do an adaptation with the airbag module. What are you talking about? Adaptation? I've never done that. Never. He goes, well, now the airbag module wants to know what the tire size is. It wants to know, is it all drive or full drive? I kid you not. I had to go in the trunk, look on a tag, and find out what tires were on the car by code. Was it 1LB? Was it 1LC? 1LD? That's the option code. That labels that guys may go, oh, what's this label? They tear it off, whatever. If that label's lost, you're done. But it was in the trunk by the spare tire, and luckily it wasn't worn off. I read numbers, put that in. Next question was, is it all drive or is it two-wheel drive? So I put all drive, and then the light was still on. Even though I did the procedure, the light was still on. What did I have to do? Turn it off, put it to sleep. Start up, light went off. Now like this. Oh my God, thank you, Nick. So Nick bailed me out twice last week. I appreciate that, buddy. But you know what? We have to network. I don't know everything. Sometimes you have to network. But I'm here to tell you that there's procedures that if you don't read a procedure on it, you're not going to know. There's always something new around the corner. So that is just reconfiguring, telling the module what it is. Then there's something called pairing a module, initialization. Do you know that if you're changing an airbag computer and you introduce him onto the car, the occupant computer who's in the seat now for child weight, because it used to be that on an airbag system, like my daughter gets in the car, my 8-year-old daughter says, Dada, airbag light's on. I'm like, oops. So I have to shut the car, put my key in there, and turn the airbag off because she's sitting in the car. God forbid there's an accident, the airbag hits her. She knows. So now what they do is they do it automatically by weight. You sit in the seat. If you're under 45 pounds, the computer will put the airbag, it'll say airbag off automatically. If I get on the seat, it'll just say airbag on, or the airbag off light will go off. That seat has to be calibrated. That computer's in the seat. When you bring a new computer on board, those guys are buddies. They're buddies. They have to be paired. They have to be initialized and go, hey, how you doing? You want to come on board? Hey, how you doing? Okay, come on board. There's a feature in the tool. Not a how you doing feature, but it's called initialization. You have to reinitialize. I had one guy screw me today. He replaced the airbag computer and the seat computer, and he tossed them both. So I get there, I couldn't pair them. Am I right? You can't pair them. Because this guy does the pairing with him, or he does the pairing with the other guy. But if neither one of them are there, and you introduce two new guys, I said, dude, you're screwed. The factory tool is not going to do it. You have to bring the car back to the dealer. They have to put on a network with Chrysler and figure out something. You just did yourself in. I'm like, why would you throw away the parts? You're not even done with the car. Oh, well, we fixed the car. But it didn't leave yet, dude. So what are you teeter-tottering over there for? You're like the Leaning Tower of Pisa. Give me just one more second here. So the idea is if you work on any car, don't get rid of any electronic components until the car leaves. Because you never know if you're going to get a wrong part, which I had one guy order a brand new airbag module from the dealer, and they gave him the wrong one off one letter code. I could not pair it to the seat. So me, like an idiot, I'm like, well, you sure it's the right one? Yeah, ordered by VIN. So I said, well, let's get the one in the seat. So we get the one in the seat, still won't pair. So I'm like, that's it. Let's rip the console out. Let me look at the numbers. I compare numbers. It was off one digit. And where's the parts guy go? Oh, it's updated number. Yeah, updated number. It was the wrong number. So understand about pairing. That's initializing. So we have reprogramming, reconfiguring, initializing. Then we have these two other guys to cover, but he wants to take a break. Is that true? Or can I go a little more? We'll go a little more. He's talking. Relearn. I want to finish this slide. Then there's relearning. Remember we talk about the non-volatile memory? What happens if the battery goes dead for too long? You're in serious trouble. I'll tell you why. You're married to throttle index. It doesn't know where the throttle is anymore. You clean the throttle on a lot of these cars where they have a throttle computer, you're done also. Because now you remove the dirt, now more air flows through and the computer goes, I don't know what to do. And the idle stays high. The manual procedure may not work. You may need a factory-enhanced tool to relearn the throttle. This is common on Volkswagen, Audi, and Nissans. Very common. Very, very common. I do them every week. Crankshaft index. Crank relearn gets lost. Computer goes, where's the crank? I'm like, what do you mean where the crank is? The car's running. How would you not know where the crank is? It wants to learn crank index. That's another procedure you must follow through GM. Well, you can do it with the aftermarket scanners. They do it too. Where they tell you, you got to follow procedure. Can't be missing. The car cannot have a miss in it. You turn the key on. Don't put your foot on the brake yet. And then when you start it up, then you put your foot on the brake with the left foot. Then you put it in gear. Well, no, sorry. Then you make sure it's in park. And when it tells you, you have to snap the throttle wide open. Whoa! All the way to the floor. And when it does that, it relearns the crank. And then you're done. Fuel trim adaption. If you have any fuel trim problems, you have to go in and clear adaptions. Or you can clear codes, and sometimes it'll reset your fuel trims back to zero. Usually when you get a new computer, these are set at zero anyways. You have to start all over to learn fuel. And the last thing is recalibrating, re-zeroing. You will have to re-zero an occupant seat for zero weight. It may require no weight, where it says, all right, make sure everything's off the seat. So you turn the key on. Is everything off the seat? Yeah. Is the seat upright? Yeah. Okay. Don't move. Hit the button. Bink. It's set to zero. Other manufacturers, Honda, which they're nuts. They're nuts. It'll say, okay, turn the key on. All right, turn the key off. Turn the key on. All right, zero on the seat. Now, place the weight of your choice. Like, 10 pounds. Place it on the seat. Okay, now drive over 22 miles an hour and maintain speed. Don't hit no bumps. If you bounce the weight, you start over again. What is on their mind? What is on their mind? Chrysler? Let's do Mercedes. Well, Mercedes is even nuts. They go seat all the way up and down. Seat all the way up and up. Seat all the way back and down. Seat all the way back and up. Bring the seat to the center. Is it true center? Yes. Now put 35 pounds on the seat. Boom. Now put additional 55 pounds on the seat. Boom. Are we done? Okay, take it off. It's like a 12-step procedure. Just to zero out the seat. And God forbid you miss one step. You're done. Also, steering angle sensors. If you do an alignment on the car, you get done with alignment, now you're married to a steering light or an ABS light. Your steering angle sensor's off. So you have to put the wheel straight, and hopefully, God forbid, your tool can go in and do a steering angle reset and recalibrate for 0%. It has to be. Anytime you touch the steering alignment, you're married to a steering angle sensor. Or if the battery's left disconnected for too long, you're married to it. And your tool may not be able to do it. I'm here to tell you that. Yaw sensor. You know what a yaw sensor is? I'll give you a clue. It's not a sensor they use out west. Say, hey, Billy Bob, give me one of them yaw sensors. What's a yaw sensor? What is it? Anybody fly a plane? It does the latitude thing. It tells the computer where you are. You need it on an ABS system. Then there's a rotational sensor. G-force. Right? There's a G-force this way. There's a rotational sensor. When the battery goes dead, you need to recalibrate these things. One of my customers had a yaw rate code. And his scanner, I'm here to tell you, his scanner, I won't mention what it was, had wheel sensor, wheel sensor, wheel sensor, wheel sensor, 4. Inlet, outlet. There's an inlet and outlet solenoid on each wheel. So that's 8. 8 and 4 is 12. They had a couple of how you doings like brake switch. So he had about 16. I had about close to 32 pits. I had one pit he didn't have. He needed. The yaw sensor, plus or minus 4 degrees. He was okay. It was within range. I checked the G sensor, was at 0. I checked the had a longitudinal sensor, which is this way. Little dip. That was at 0. Wasn't in the scan tool. Then I did something else. I looked to see what I can do, functionality. I can apply every solenoid and bleed and do a bleed wasn't in his tool. Then I did something else that he couldn't do. I went another functional procedure, said recalibrate steering angle sensor and yaw sensor. It was one whole operation. I hit the button, boom, did it. And I was a little mad that he had none of these features. Why? It's to save money. Someone picks and chooses what they want to put in your tool. So understand that you may have a tool, but there's no guarantee it will be like factory. There isn't, because it's all about money. Let me tell you something. If you want to duplicate a factory tool, it's going to be a lot of money. So if you want to specialize in enhanced work, you may have no choice but buy a factory tool. You can get by a lot of stuff, but I'm just here to tell you that whatever you see in your tool may not be the full Megillah. And the last thing was computerized headlights, another issue. Battery goes dead, you may have to relearn the headlights. Because you'll see a little picture of a headlight with a beam going down, you're like, what the heck is that? I have to relearn the headlights. You have to go in, command the computer to hold the headlights in a certain position, then it'll tell you to adjust the headlights. Then when you're done, you say, learn it, and it learns it, and it stays there. Once the battery goes dead and you touch the headlight, you're done. You have to reprogram, you have to recalibrate the headlights back to zero position. The ones I have trouble doing, I really tried. Jaguar has these eyeballs, they go, bloop, 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 bloop. So you go on a turn, they go, bloop, bloop, bloop. I mean, have you been successful with those? Dude, they're a nightmare. But the other ones will just go, as you go up a hill, they adjust. Those are not a problem. But I'm just here to tell you, when batteries go dead for too long, you're married to a lot of stuff. And one more thing, and that's it. I'll let you guys go to break. I do a yaw rate adjustment on a BMW. Where's my BMW guy back there? All right, Pierre. Maybe, I'm going to see if you know what this is. First I'll ask if anyone knows, and if they don't know, I'm going to see if you know. I did the guy put a brand new ABS control in the car. He has a light on. I have to recode it. After again recoding it, now has a code saying I have to perform the steering angle sensor. So when I do it, it does the steering angle sensor and the yaw rate all one shot and the G sensors. I get done, and the light's still on. It says, you must perform the end-of-the-line test. What the hell is that? Does anybody know what an end-of-the-line test is? Because I didn't. Do you know what it is? Nick, you don't know what it is? Because I don't know what it is. I had to do a little research because I had to get paid for that job, and the light was still on. What is it?
You should have called me. It is the three sensor alignments: steering angle sensor, lateral acceleration sensor, and rotation rate.
Which I did, and I was successful.
That's what the test is. But it doesn't always recognize that the test was done if you do them in order. Sometimes you have to mix up the order.
But I did them in order.
But you have to mix them up.
But no, you didn't do it yet. It's an end-of-the-line test. Look, I know what an end-of-the-rope test is because I've been there. But end-of-the-line test, I'm going to tell you what it is. When you get all done with all three Megillas, no, you drive it, step on the brake, because that's what they do at the end of the line of the assembly. That's why they call it end of the line. They step on the brake, so it sees brake pressure. You put it in park, shut the key, you're done. I didn't know what an end of the line test was. Did you know that? So when I got done with all the Megillas, I did it right. I did it right. But it says, you must perform the end of the line test. What is an end of the line test? Who thought of that? So when the car is done at the end of manufacturing, it gets to the end of the line, there's a dude he's got a patch that says, end of the line tester. He gets in the car, he steps on the brake, and he shuts the key off, and he's done. Is that amazing? Well, when you start up, light goes out. It's just amazing to me. The reason why I went over was programming stuff, because this next slide is on programming. So I know what's going on here. We're going to go through this guy. The main complaint here is 2006 Dodge Durango, 4.7 liter, ABS light is on. All right? The car was worked on at a body shop. It was there for quite a while, and the end result is the ABS light's on. No big deal. Go in there, hook up the scanner, pull the code, and it'll lead us to what the problem is going to be. The code I got is code C2202, original VIN mismatch. What's C stand for? Chassis. What would B stand for? Body. What would P stand for? And what would U stand for? What? U.
Female sheep.
I'll give you a hint. You ever watch the movie with Robert De Niro and Billy Crystal, and they're facing each other going, You. No, you. No, you. So it's a pointing. It's a you. It's pointing direction away from the module. It's saying you, not me. Must be an M code. You. So if you have a U code in a module, it's diverting attention away from itself. I divert attention to myself, so I'm a me code, right? It's a U code. So don't go looking in that module for a problem. The problem is not there. It's out on a network. So it's just allowing you to know there's a problem out on a network. Understand what a U code is. It's a network problem out there of the guy who's complaining. It would be nice enough if you got all the guys together. And so all the U's, the one guy who isn't a U, he's probably the one they're pointing fingers at. Just comprehend that, right? Just to make it easy on you. So I'm in the ABS module. This thing go dead on me? I just bought this thing. Oh, the thing got loose. Look, I diagnosed it. A loose connection. Huh? Hey! How you doing, huh? Oh. I diagnose anything. Just can't diagnose the ex-wife, but everything else I got going. Yeah. Yeah, put the liquid on her. Yeah. Get her all enhanced for me. That's an enhancement. You know what I'm talking about? That's an SL, slut, 22. Make her into a slut. Original VIN mismatching. So the ABS is saying somewhere out there, one of the modules is not VIN properly. So let's go to the network, right? We have a, look at this, we have a radio, we have a code in the TCM saying battery was disconnected. Maybe it was disconnected for a long time, or maybe someone tried to disconnect the battery to get rid of the code. ABS module, seen a mismatch somewhere. Here's the CCN module, which is a fancy name for the instrument panel. And it's saying a vehicle configuration problem. The front control module is saying there's a missing VIN. Front control module is a dude who's in the front. He's in the engine compartment. He could be part of the fuse panel that's attached to himself. And he may go, did you step on the brake? Oh, you did? Hey, rear module, put the brake lights on. Because that's what it boils down to. That's why I have all these modules around the car, to get rid of a lot of wirings. It's all done by calls. So there's the front module. He's complaining. The occupant control module says battery voltage is low, but look at the occupant classification module. He's the one that classifies the weight of the person in the seat. Then there's the occupant restraint control module. He's a little pissed. He's saying vehicle configuration data, and that's about it. Those are the guys that are complaining, but I don't see the PCM on here. He's not showing up as a code. He probably thinks there's nothing wrong with himself. So we're going to go here a little step further. I go to check the VIN in the PCM. I go, let's check the PCM VIN and validate it. Now I'll ask you a question. Why are there 2 dashes in this VIN? PCM wasn't changed. The car just sat around in the body shop for about maybe a month. I don't know how long it would take if a car gets hit, how long it takes to repair it. It could take a month depending on parts, 2 months. But when they put it all together, that's what I got. Volatile memory problem. And I got news for you. It ain't just this Magilla. It's quite a few of them. This is like number 10 for me. There's something going on with volatile memory in these vehicles. Chrysler better fix it. They're going to have a serious problem on their hands. So what I have to do next now is I have to fix the VIN. So I go in, I enter the VIN, I put the VIN in, and I hit next. And it goes, VIN is valid. Press finish to exit. I'm all done. I go in and I cleanse the whole network, which is nice. They have a tool that looks at all the modules instead of going in one, then into the next. I mean, eventually, other scan tool companies will decide to go, let's do the whole network check instead of going in and out of each one. This is a good feature that not all manufacturers do it, some do it. They show them all on one page. So I cleanse them all, and none of them are, no more codes, but what do I need to do? Shut the key off. And I got news for you. Don't just do it for 10 seconds. I have a new rule now. Do it for 25 seconds. No, 30 seconds. I'll tell you why. I was checking bias voltage on an ABS sensor that was had a problem on a car that got hit, and I was checking the bias voltage, and I'm like, Where is it? Right? It was there a minute ago, so I want to test it again. And I waited 10 seconds, turn the key off, turn it on, wasn't there. So the guy's like, maybe you're not waiting long enough. Dude, I'm counting 1 Mississippi, 2 Mississippi. I'm not going 1, 2, 3, 4, 5, 7, 8, 10. You know, I may be like fidgety and fast, but I'm counting up to 10. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4. And I got news for you. I had to do 25 Mississippis to put it to sleep. Then I turned it on, there was the bias voltage. The car had a bad wheel sensor. That was a problem. But I didn't wait long enough. So I would say do the 30-second off, 30-second on. You have to do 3 key cycles to do a comprehensive test on most modules. This is not all about, you know, the monitor comprehensive test for PCM. This is on all computers. Put them to sleep for these 30 seconds. So then I do that. I get done. And now I got this tire pressure monitor light. So body shop goes, what's that evidence? I don't know. He goes, well, the lady don't have tire pressure monitor in this car. What are you talking about? There is none. I know for a fact that she don't have it. I'm like, how could she not have it? She's got to have it because the light's on. He's like, dude, I'm telling you, she don't have it. Never came with the car. I even called the dealer up to verify it don't have it. So what happened there? How does it not have it, but now it does have it? Car didn't come with that. Lights on. And then I go into the instrument cluster, which is called the Cabin Compartment Node, CCN. There's a lot of acronyms in this business. There's only one I worry about, PMS. That'll kill you. That one you got to worry about. That one you better know what it is. This one here, CCN, you immediately look it up. It's instrument panel. So in there I got right heated seat, low indicator control circuit low, right heated seat high. Car don't have heated seats. What, all of a sudden I got heated seats overnight? 2 months it sits down for sleep, it wakes up, it's got heated seats? What the heck's going on? No welding. Just lay dormant, woke up and said, who am I? Where am I? Annie M. Annie M. What?
They made the same part for more than one unit? And they had to...
No. They just worked on the car, put it together, and this is what they got married to. Turns out, we're not programming this car. What do you think we're going to do to this car? This car's been flawed over time. Its non-volatile memory, it just became like a rash. So, coding or, what's the other word? Configuration. The only problem with Chrysler is you can't configure one module by itself. Like on other manufacturers, you can do one at a time. Chrysler, you have to do the whole entire car. You have to give it what I call it the configure enema. That's the only way to describe it. So you have to put your tool online and pay the price for the day and do this program is used. See, it says restore vehicle configuration. This program is used to download vehicle configuration data. This should only be done if the vehicle has lost its configuration. Oh, really? You must have the vehicle's VIN for this function. So basically what I did was I went on Chrysler website, I entered the VIN, and I hit it, I waited, and then it did its whole enema. Then when I got done, what did I have to do? It told me to turn the key off and wait 15 seconds, and I did. When I did that, problem was resolved. All gone. It lost the memory of configuration. So did I program the car? No. Did I calibrate it? I reconfigured it. And you can't buy reconfiguration information. If you buy a reprogramming software subscription, it don't include configuration. This is not something you can buy. You have to go get it from the manufacturer in different ways. Like Ford, you have to go on the website and get the as-built data and put it in manually. Other cars, you have to log on and let the manufacturer straighten the car out. But you have to pay for that. You have to. So just so you know that when batteries go dead, certain cars may lose relearn procedures, calibration procedures, zeroing out procedures, or configuration. And I had about 8 more of these. I'm telling you right now. I had a dude, I put on my website, I'm not kidding you, from Nebraska, email me because someone on ITN said, go check out John's website. There's a story just like the problem you're having. He called me up. I helped him out. I helped him out over the phone. I'm like, dude, I've seen it already. Here's what you got to do. He had the factory tool, and he did it. He thanked me. But he didn't pay me. He didn't send me a check in the mail. He should have sent me something. You know, here's a little money. Take you and your girl out to dinner. Damn it. Damn Westers. Now, okay. I got to take a seat here. Ah, it's a wonderful day in the neighborhood. A wonderful day. Hello, boys and girls. I'm here to tell you a story, boys and girls. It's a wonderful day in the neighborhood. I'm going to date some of you guys back. I'm so happy. I'm so happy. They should be. You're supposed to wear them over shoes, but I don't have the proper shoes because these big McGillis, they don't work. I'm here to tell you, if you're working on hybrids, you better take every precaution necessary because, you know what? There's no hybrid taking out the tech man. I'm telling you right now. My buddy gave me these shoes because he works for PSC&G. These things are rated. What's the rating there? 15,000 volts? That's what they're rated at. They have to wear these. All right, so, because I remember I was at a body shop and I was standing over the battery and I'm saying to myself, am I supposed to do this? Because I was in the back testing stuff with these gloves. And I'm thinking, I should wear something for my feet. So I told my buddy, he goes, I'll give you these boots for nothing. They're very expensive boots, but he gave them. He's my neighbor. But you need to have gloves that are rated at about 1,000 volts. And these gloves have to be tested like every 3 months for holes. Because you have a hole, you're going to have a problem. Or it could be a good problem if you have a hole. And you want to wear these gloves when you're disabling these cars. They're all going to have some type of battery plug on them in the back for you to disable. So if you're going to work on this car, you better find the plug in the back. They're all going to have them using the battery, and you're going to put it into disconnect mode. Then you can work on the car, but you have to wait a little bit. Just wait maybe 10, 15 minutes for the capacitors on board to dissipate, or you can take one out and throw it at one of your buddies, and it'll dissipate right away. Like we used to do in the old days, the points condensers. That's a little mini capacitor. These big boys will take you out. So you wait a little while, then you can work on the car and do what you got to do your repairs. And if anything that is orange, that's damaged, just do visual on it. Make sure that there's anything orange, the insulation's okay. And if you're going to start testing, you have to get one of these McGillis. I think this meter's like $500. It's made for hybrid cars. It's a Fluke 1587. It comes with these special leads, and you'll notice these leads have ends on them like you have a sword. It has a little shoulder on it that kind of keeps electrons from flowing over straight back into your fingers. So they're special leads. Meaning that if these leads go bad, you don't go to Radio Shack and get replacement leads and say, how you doing? Because you'll have a problem. So the bottom line is you want to take precautions. I'll pass these leads around so you can see what they're all about, but they are special leads, and they go with the meter. And so if you want to disable the car, you want to put your gloves on and do things right, and then work on it when the car is dead after you've properly diagnosed the car. All right? I may have trouble walking with these because they'll slow me down, so I have to put them back in my box. But, you know, that's just the Mr. Rogers routine. And I used to watch him when I was a kid. He was a pretty cool guy. I just didn't know he was gay. That's all right. It ain't a bad thing. He was a good guy. He told a lot of good stories. So I figure if I tell you a story with the boots on, it'll get through to you that you must take, as silly as it looks, you have to take precautions. You don't want any problems. You want to be around to see what happens to the car when you get done with it. So I get this hybrid, and it was at a body shop, and when the car got whacked, it hit something underneath on the trans, and it broke the support on the transaxle. So they had no choice but to replace the whole entire transaxle, and to save money, they bought a used one, same year, make, model. It's no big deal, because those things are very expensive. But they farmed it out to a repair shop to do the job. So repair shop, took precautions as well, put the transmission in, and the car did drive there, but then it never started ever again. Never, ever again did it start. And they gave it back to the body shop and said, look, we got the trans in, but it don't start. Look, we got it in. That's pretty much most of the job. So they called me in for a no start after transaxle replacement. And I'm going to tell you that on a lot of these hybrids, if you got the triangle of death, the little triangle right there, that car is not going to start. That's the triangle, that's the devil's triangle of death. That car will not start. There's something wrong with it if that light comes on. They have another one, it's a picture of a wrench. It's like a little amber wrench. That means that problems are going to happen. That's kind of like a little, hey, how you doing? But you have this guy, you're done. Something is wrong. There's my boots. We talked about that. Now, what I did was I'm like, you know what? Let me see what codes are in there. I pull the code, and one code is, these are different codes, not the kind of codes that you're used to. P1A10, hybrid PCM, battery has been disabled. Now I read the codes. I try to figure out what they're all about by understanding code definition and try to go somewhere. I try to dot the I's and cross the T's without getting too high tech. Because see, you can analyze the car or you can analyze the car. They're spelled almost, are they spelled the same way? Analyze, analyze? I think they are. So analyze the car. We have a P1A14 hybrid PCM transmission disabled. Okay? Then we have a U code. U. Hybrid PCM, CAN communication bus fault. So it's pointing a finger out there in the network. So not only is it disabling the battery and the trans, it sees a problem in the network, and then the trans computer is saying POAOA, high voltage interlock circuit. I'm like, you know what? Maybe they did something with the plug. They probably didn't put the plug in right. I'm like, yeah, that could be an easy one. Let me go look. It could be. So I go back there and inspect the plug, and this plug is in the trunk, right? And the battery's running underneath this whole assembly. But if you look, see a little dot there? It says lock. And another area here, if you put the dot, if you turn it, it'll be unlocked. That's where you take it out. There's another spot here for shipping. What they do with the manufacturer, they put it in that spot so the plug won't come out, but it'll be unlatched. But I said, well, they did the right job there. It's properly in place. But let me do one more thing. So what I did was I said, let me just take it out and I'll test it. I put the rubber gloves on, and there's a fuse in there. There's a huge fuse in there. So I just ohmed it out to make sure the fuse is okay. Just to go one step further, because I'm thinking it did say battery disconnected. So I ohmed it, and I'm like, damn it, that's not the problem. What do I do now? So, you know, I'm not a specialist on a hybrid. I just try to learn as I go. But I have to investigate and research. So I'll tell you, I had to call up G. I said, G, help me out here, because I don't know. What am I overlooking? He says, John, these cars Ford's a little special than other hybrids. They're using an inertia switch. So when a car gets hit, it cuts off the electricity to the battery. I'm like, dude, come on. I know there's an inertia switch up front for the fuel pump because I saw it. But in the back, what they did was they put an inertia switch right there where the jack's located. Who would do that? Who would put an inertia switch in the back for the battery to disconnect next to a jack? And then G told me they had one case where the jack came loose, banged the inertia switch, and the car was disabled on the highway. So when the car gets whacked, you got to check this inertia switch back there. It's a culprit. So I'm like, yay! So I went like this, thank you, G! I hit it, and then what I had to do is, if that was it, it ain't going to start till I what? Turn the key off. We have to do, on a hybrid, you have to do 3 start attempts, cycling. Wait 30 seconds, turn it on, push the button. Ain't going to start. Turn it off, wait 30 seconds, you have to try 3 attempts. I did that. Still wouldn't start. I'm like, damn it. The switch was hit. So I said, let me check the codes again. I got a code P1AOF, hybrid PCM vehicle disabled. It's disabled in the vehicle. And if you look at this, I had to go on Ford's website to do a little homework. I said to the guy, you know what, dude? I tried this, I tried that. Let me leave. I spent my hour. I got to go home and do research. Because at that point, I didn't know what was going on for me. I had to do research. Because if you're no further than 1 hour from where you started, you've got to get off the job, go do something else, and go home and do your homework. I found out on Ford's website that this code was a code that was a fail-safe mode code of the PCM called LOS, Limited Operating Strategy. So it's going to limit the operation of the vehicle. It may just say, LOS, you're walking, because it sees something wrong. And this code, an LOS code, may not be created by the PCM. It could be created by another computer or network that tells the PCM to disable the vehicle. So they tell you to make sure there's no other codes associated with this problem within the PCM. And there wasn't. The only other code I saw in the PCM was a U code that basically said, CAN communication bus fault. All right. CAN communication bus fault. A U code stored to direct attention away from the hybrid PCM. We talked about that. So then I go in and look up this. I have a TCM code. Theft detected, vehicle mobilized. The transmission computer saying, theft detected, transmission mobilized. Was someone stealing the car? Because you're still here. Why are you complaining? If you go on Ford's website and look up this code, the scan tool says, theft detected, vehicle mobilized. You know what Ford's website says? Data mismatch. go in and check the configuration of the PCM and TCM. I'm like, dude, did you change the PCM? No, we didn't touch it. Would you change the TCM? No, we know what the hell it is. So I do more research. The trans computer is inside the transmission. So I go, all right, I'll configure it. I go on Ford's website, look for configuration data there is none. I can't even configure the module. So then I read a little further, and it says, you got to do the how you doing. I'm like, I got to do the how they doing. What are you kidding me? So I went in. You have to go into the anti-theft system and do something called parameter reset. On a Ford, to do the how you doing, between an instrument cluster and an engine, between a PATS module and the engine, between the TCM and the PCM, you have to do a parameter reset. Required when a new PCM or PATS module is installed, they should have had on there, or TCM. Why would the TCM be involved in the security process? It shouldn't be. But the problem is if someone is not welcomed on board, the anti-theft gets latched. So all this car needed was a parameter reset. So I did that, and I cleared the codes, and what did I do after I cleared the codes? Start up, I'm like, yeah! And all the guys at buy shops were like, yeah! I'm like, yeah! I was hugging guys. I'm like, they were like, oh, calm down, dude, calm down. I'm like, I got a hybrid running. But you see how the process of reading into the codes to see what the definition is all about, but then I had to stop, because you can only go so far with a definition of a code. Now you need help. You got to do research. You can't call your buddy up, hey, what would you do with this hybrid? He didn't work on a hybrid before. So I went to G-Man. I said, I got all these crazy codes. What are they all about? I never heard those codes, so I researched them on my own. I spent a couple hours on it, working at night. I didn't care because I wanted to learn. It was the learning curve, so I thought, I'm letting you guys know what can happen out there. They replaced the whole trans, but the module's inside the trans. A lot of manufacturers are doing this now. They're putting the trans module inside the transmission because guess what? He's closer to the solenoid. He's closer to... It's all closest now, bringing everybody into one area. Plus he's going, look at me, I'm in trans fluid. Like, I'm cooler now. Craziness. Dude, it's craziness. All right, we have another one here. 2000 Lincoln Town Car, 4.6 liter, no start, no communication. What do we have flashing on the dash? Theft light. So that indicates we have a theft problem of some sort going on here. Now on this vehicle, you can see the network. See the purple and the yellow? Those are networks. Look at the airbag module. He's all by himself. He's like, I don't want no part of you guys. I'm dedicated. I'm more important than all you guys. You can play. I'm saving lives. So he's on his own network. That's Ford's decision. But I said to the guy, all right, you can't talk to the ECM. You replaced the ECM. You checked all the powers and grounds on the ECM. He's got no communication with the PCM. And if I go into, what's something I can do? I went into the PCM, and my scanner can go into other modules. What am I going to do? Am I going to look for this? Pointing fingers? It can help, right? You want to look at all the modules to see if they're pointing fingers as well. And they were. I went to the instrument cluster who's in charge on this car for anti-theft. He set a U code for this guy, for ECM. So I knew that not only my scan tool couldn't talk, neither could the instrument cluster to the PCM. Understand that your scanner is nothing more than a node. And all these other computers are nodes too. They're all hanging out in the network and they're all talking. So if this guy can't talk and I can't talk, there's something going on. And here's why I screwed myself a couple times. Where I go in, no communication, I check all powers and grounds. I'm like, I'm probably to PCM. I've been there myself. I'll admit it. But I overlooked one thing. I never checked the communication line. I never checked to see if there was a problem with that communication line from the data link connector to the ECM because it can happen. So I just did something like this. If you're going to check communication line, you're going to need a scope. There's no two ways about it. You need to look at activity. It's fast activity. You don't have to be a rocket scientist. You just need to just take a picture and see what it looks like at a good area, which is at the ALDO connector, because I know the network must be working because I'm talking to other guys. So I have this OBD2 breakout box, and by the way, you can get them from AES Wave on the back of your magazine thing here, your booklet. There's a company called AES Wave. They sell the OBD2 breakout box. It's a great tool if you don't want to be underneath the dash where you're back like this and get a pinced sciatic nerve like I had for 2 months, because that could hurt. So you get one of these boxes, you plug it in. There's your 12-volt source battery feed. Pin 4 and 5 is your grounds. So I know these two are the can line, those two can lines. So I put the yellow here, the red there, and I took a picture of them. And then I went to the other two at the ECM, and I put my green and blue there. I'm just comparing notes from one end to the other end. And I put on a scope, here's the good boys, here's the bad boys. I ask you something. Without being a rocket scientist, I noticed that this thing goes from 0 to 5 volts. And it's going yada, 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 yada. These are packets of information. Yada, 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 yada. That's all I know. It's talking. It's somebody talking all the time. Blah, 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 blah. This guy here, what do you notice about him? He don't talk much, but look at this. Is he ever getting high enough? Is he ever getting high enough? The voltage is low. He's not getting high enough. So what did that first come to your mind? No, well, it could be partially grounded. Yeah, I like that one. What else could it be? High resistance. So I'm thinking, you know what? This up here is good, down here is good. I could have just ran 2 new wires if I wanted to. But when I wiggled the wire, these guys kept changing here. I wiggled it down there. I'm like, there's a problem somewhere down here. Where?
Bottom 2 are the ones on the...
Bottom 2 are the ones on the ECM. Okay. The top 2 are the ones right at the ALDL connector to my breakout box there. So it's funny that when I wiggle it, I have a problem. I'm looking a little closer. I lift up this panel. And ask a question, what is this thing? No, what's this thing on the body? A weld? What is this thing going across? And what is this nice, how you doing, high-tech, fibrous, rolled around the harness to protect it forever stuff all about? Did it work? Look at it. Look at that nastiness. It rubbed through over a period of time. And I found that a lot of Lincolns are having this problem. This ain't the only one.
Where is that right there?
That's if I unzoom it, it's right there in the wheel well. You take the tire off here. This is the wheel well opening. I had to pull the wheel well housing out of the way, and that's where it was laying, right there.
On the driver's side.
On the driver's side. Yep, left front. And now I dig a little deeper, and look at this. I just touched the wire, and it broke away. It was actually laying right here a little bit, and it was all corroded up. It severed, and it was all like corroded up. So you see, and I didn't write a story on this one yet, but I'm going to call it Gilligan's Revenge. The poor guy was on an island. He was isolated from everyone else. He's going, help, help. He was off the network. He only came off the network. Everyone else went on with their own business. Into the customers going, hey, he left. He left. Elvis left the building. Let's find him. Elvis sighting in the wheel well. So a computer can get taken off the network and not communicate, but still be okay. So understand, if you get no communication, you better validate powers, grounds, and our new Megillah, a shorted reference power, reference voltage line, or a communication line that's flawed. Or, the last thing would be, how would you like to have a couple of Nissans, which I had a couple, that failed inspection because they wouldn't communicate. And they were bad processors. They would not communicate, but yet they worked fine. Car startup, everything else. Nissan, I had a couple of Nissans. Those are the ones that are up in the cowl there on the right-hand side. They're buried. There's something going on with them. But you will have certain cars that may not communicate. You have some cars that communicate on one side, OBD2, and not on the other side, enhanced. You know, you don't know, but you still have to validate these wires. So that's the problem with that poor guy. And there it is after I fixed the wires. You see how everybody's happy over here now? And then the car started up. Because now the ECM went back on the network and the instant customer commanded him to start the car. But it can happen. ABS apply on decel. This becomes a big problem. How would you like if you had a car that had no data and just codes? There's no way for you to look at the car. And you slow down, the car's perfect. But as you slow down, you hear, I know you all been there. Cars roll along fine. As soon as you get to like 4 miles an hour, 3 miles an hour, and then if you did have data, you're on your scan tool, you see 6 miles an hour, 5 miles an hour, 3, 3, 3, 3, 3, 3. Why does it say 3? Why don't it go 3, 2, 1, 0? There are certain scanners that do that. Because most computers can't see creep. They can't see creep. And when it gets to that low, they don't calculate anymore. But if you have a problem that's around 4 miles an hour, and you get near that just before a creep point, you'll get a pulsation. It goes into ABS supply because one of the guys is not giving enough AC. We're going to talk about how AC works. I'm going to show you something. The only way that you could check this problem, even if you had data, you wouldn't nail it, because you need to look at the amplitude of the signal. And the next slide, we're going to go over that. I just put let me see one thing. Is the AC thing the next page? Oh, it is next page. That's the next page, right? Good. Okay. Is it? Oh, yeah, it's next page. Good. I just put a 4-tray scope on it. Just to give you an idea. This is the 2 front ones, and these are the 2 back ones. I can tell you that this guy here in the rear and this guy here, they're not bad. They're normal. Why is this guy bigger than that guy? Is that a problem from front to back? Don't ever compare front to back. Never, ever, ever, ever. You always do side to side, because the backs could be different and it can be calculated within the processor because it knows of the different resistance. Very good. So you always do side to side, never front to back. And another thing too is, I had one guy, he never came across anyways, but he did something one day. I'm like this, dude, you're kidding me, right? He had a scope on the wheel and he's spinning it, going, yeah, this one's working. I have good AC. And he goes on the other side and he checks the other side. He goes, yeah, this one's working too. I'm like, dude, what are you doing? I'm checking them. Dude, you're not comparing nothing against nothing. I says, how about you stay on that side, I go on this side, we'll spin them together and see if we can keep up momentum with each other and we can test it. Drive the car. You need to drive the car and have the same exact wheel speed to check these guys. All right? So let's just compare this guy to this guy and this guy to this guy. All right? I'm going to zoom in a little bit to show you what because I have the scales at +5 to -5. So from here to here would be 10 volts. All right, the amplitude would be 10 volts, okay? And these are all 5 to 5. So let me zoom in to show you what they really look like. So before I do this, I got to make sure you understand about AC and how it works, okay? These are magnetic sensors, not magnetic resistor. Those are the ones that do square waves. Magnetic sensors. You have an iron core, just like the old days, right? And then you have a field coil around that iron core. The strength of this iron core will determine how strong the AC signals be, the amplitude, how much AC puts out. The resistance of the field coil will also determine how strong the AC is going to be. If you have high resistance in the field coil, the guy said to me, I did go in and check the resistance of all the field coils, which is pretty cool. He checked them all. He was smart. He wanted to make sure that they didn't have high resistance. Also, the air gap between the magnetic wheel and the iron core determines the strength of it. The speed of the shaft determines the strength of it. The magnet. Tell me you didn't have this years ago, where you had like maybe a Chevy, throttle body injection, car runs great, 1,000 RPMs, gets down to 700, 550, boom, it drops out. So you're like, all right, guy puts an IAC motor in it, puts an ECM in it. He's saying, well, maybe it's cutting out, puts a module in it. He's like, puts a pickup coil in it. It's like, this thing keeps cutting out. So he does something like this. He cranks the screw up, holds it above 800 RPMs, he's good. He's like 700 RPMs in drive, he's good. If it goes down to 550, it craps right out. What happened was the AC voltage was so weak that when it got to 550, it didn't cross over because you need at least, I'm going to say the magic number is at least about a half a volt of AC, at least, before it gets digitized through the computer into a square wave. Because you have a digitizer in the computer, it's supposed to see half a volt of AC converted to DC. The computer goes, oh, okay, it's moving. If that device puts out like 300 millivolts, 0.3 AC, right, it won't be seen. So what happened on this truck was it had a bad magnet. It was all deteriorated. So when it got to a low RPM, it just didn't work as well, and the module like, oh, okay, I have no more signal, let me shut off. And that's what was happening. All that car needed was a new magnet, a new shaft. Very common back then. So understand about AC. As the speed increases, the frequency increases. You get more little oscillations together, right? This is speed. Between here and here is speed. But you also, the amplitude is going to increase as well. So understand that all these factors, good magnet, speed, good iron core, not high resistance, and air gap. So with that, let's take a look here. This is as I'm slowing down. This guy is 2 volts to 2 volt. I got 1 volt. I got almost 2 volts of AC. We're doing good here, right? Now I zoom this thing from 0 to 0.2. 0 to 0.2. I got 0.1, 0.15. Is the computer going to see that? 0.15. I already told you it's 0.5. 0.15. Doesn't see it. On deceleration, it still sees this guy, 2 volts. He's like, yay, I'm at 2. You're at 0.12. Loser. This guy over here, he's at 1 volt, actually almost 2 volts peak to peak right here, like half a volt, 1 volt. He's at 1.5 volts. He's happy too. 1.5 volts. This other guy has a little bit of a problem, but he's just making it. 0.2, 0.4, whew. He's just at 0.5, 0.6. He's still good. He's in the back. These guys are in the back. So that's the right front wheel with a problem. Now, why would the right front wheel be less than the left front wheel? Now, the guy measured the resistance. Let's do visual, because I'm a visual type of dude. I'm going to analyze. All right? Let's take a look here. Oh, shoot. Let me back up. No one look. Nobody look. Oh, my God. Previous. All right. And previous again. Shh. Jump the gun there. Okay, look. I want you to see something. Oh, my God. Guys, be quiet, okay? Oh, my God. All right. I have to hit the custom button. There you go. You see over here how the bolt holds this flush against the spindle? And you see this here, how it's real nice. And that's the sensor going in, reading on a trigger wheel inside the housing. All right? Now look at the other side. I want you to see this. Look at that. The bolt is tight, but look at this. Look at the gap there. Would you say it's like a 1/16 of an inch or 1/32 of an inch? Remember we used to use the old feeler gauges from years ago? I would say that's, who would you say, 1/16? Maybe? Right? So that's a pretty nice gap in there. But then I took it off because I was concerned you couldn't tighten the bolt anymore. You can't. So I took it off, and look at that nastiness. What would you do to fix this car? Get a new spindle. The guy didn't have much money. Yeah. So I took a hammer and a chisel. I chiseled off all the pieces. And then we took one of those little cookie pads, zip it, and it laid flush. I'm like, we're doing good here. We're doing real good. And then, here's the end result. I got to show you this. Just by doing that, I made it better. It went from 0.4 to 0.2, 0.4, 0.5, 0.6 I picked up. I almost tripled the amount of AC by just closing that 1/32 gap. That's how critical it is. That's why you get a lot of these trucks. I've seen a lot of GM trucks have the same problem. Where the guy's like, oh, you're going to need a whole new spindle. For what? Machine it down a little bit. Get a little depth gauge. And just go back to the old days and measure the depth between the outside housing and where that trigger wheel is. You'll fix them. It just wants more AC. You bring it in closer. I mean, you got to watch how close you bring it in, because then it's going to hit. Right? But understand that that little gap means a lot in the AC world. Means a lot. An air gap. That will kick a lot of guys' butts. Trust me on that one. 98 Chrysler Sebring. Check engine lamp on. Rich operation. Rough idle. All right? I put a generic scan tool. No big deal. And by the way, the guy did replace the distributor, because they do go bad on these cars, 2.5s, they go bad all the time. They have weak coils. And then what happens, you don't get enough spark and the engine floods. That's what's happened to him. The engine was flooding out, hard starting, but his plugs were fouling out. And so the codes I got in there that I saw was cam center position, You think that code came with the car, or you think he might have created it? He might have created it. He might have the connector off, who knows. But I was interested in this one. No change in map from start to run. You know, Chrysler for years, even from the early 80s, they've always set code 13 and 14 because they will actually look at the map value. When you turn the key on, it sees 4.9. It expects to see a certain drop in that map voltage. When you start the car, it'll go down and come back and level out like 1.2. It looks at the speed of that and determines whether or not if the map is properly working, or whether they have a clogged line. I remember we used to put little bleeder lines on them, where to relocate the map line, updated map sensor, but I know that's been there for a long time. So obviously, it sees a problem with engine vacuum, which could be valve timing, ignition timing, I don't know. But you know what? With the car running, let's look at basic pits without getting too high tech. All right? Engine vacuum at 5 inches, so it's not breathing too good. It's got a problem there. Coolant temperature, 217 degrees. Intake air temperature, 260 degrees. And fuel trims are at negative 25 because when the computer sees on a speed density system, if it sees low vacuum, you know what it does? Come on, fuel, give it all. Then once it gives it all, there's a dude inside going, I'm the strategy dude. Take it back. Take it. So it's kind of like a cat and mouse game. But what do you see here that you really don't like? Why is it that high? Wait. Can the intake air, oh my God, be hotter than the coolant? What? Well, what was that? Exhaust is hotter than the coolant, wouldn't you say? Maybe there's exhaust in the intake. How would that happen by some EGR? So I'm like, dude, 260. I think you have EGR. That's why it's important to know, is it in the intake or is it outside the engine? So because in the intake, I'm like this, I'm like, oh, 260. Where'd that come from? So what's the easiest thing on a Chrysler to check to see if an EGR is on? What do we have next to the EGR valve? Conveniently located, but EGR valve. Well, how you doing? What is it? What is it? It's a little back pressure port. Should there be 2 inches of vacuum on that back pressure port? Shouldn't be. So, but there is a tube, a metal tube, that runs along the back of the engine there that goes from the EGR valve to the head area, and it's very, very hot. Because on that day I had my rubber glove on, and I touched it when someone, and I had to peel it off my finger. That hurt. So watch out for that tube. It's very, very hot. So all I did was I loosened up the tube, pulled it back, and I stuck a piece of cardboard in there. Look how many inches I have in that tube. 15 inches of vacuum. Would you say the EGR valve is on? And all of a sudden the car went like this. Ooh. Look at this. Look at the readings now. Now the air temperature sensor came down below the coolant, and gradually the fuel trims were coming back to normal, plus or minus 10. But you know what? I pulled it back out, and I saw something amazing. Remember, I was doing this whole class, sitting in my bed for 14 hours, hanging out, getting out every now and then to go to the bathroom, eat, whatever, and watching Gustav. Was it Gustav the Hurricane that day? Yeah. And when I saw one of my slides, I went, oh my God, I know how trim works. And I never knew how it really worked. I'm here to tell you. I really never knew how it really worked, so I'm going to turn all you guys onto this. Because no one ever explained it to me. But pictures tell the story. So you got to follow me on this, all right? I never knew. Well, I knew in a way that the short term is in charge. The short fuel term trim is in charge of keeping the O2 to make the how you doing. When the O2 goes high, rich, the short term goes low to lean them out. So the short term is in charge of the O2 all the time. He's constantly moving that guy. He's keeping the guy in control so that he's constantly going rich lean. So if I were to literally cover the O2 screen and you couldn't see it, and if I saw the short term trim moving, wouldn't you say the O2 is moving? It's got to be moving. If I had a lean air fuel ratio sensor, that some guys tell me how it works, what current, and you have to put it in series and measure the current and this and that, and you can't disconnect it because then the O2 heater's disconnected, it won't work, it needs so much heat. I'm like, dude, I'll look at the short-term fuel trim, because if that's moving, I know he's moving. So with that, let's look at this. Here's my short term, right? See how it's moving up and down, and this guy's moving up and down. I took the paper out of the tube, create a low vacuum condition. What's the map going to do right away? Add fuel, because it sees a low reading, right? Oh, sorry, it sees a high reading, low vacuum. Look what happened here. It dumped fuel. It started running real rich. Who came first? Short terms, both of them. They went for a drop, and look who came right behind them. Because the long term's job is to control the short term. The long term is only there because his job is, end result, to bring the fuel to a point to keep the short term plus or minus 5. That is fact, because when he saw this guy drop real fast, he went, oh, I'm right behind you, buddy. I am right behind you. I'm the other troops. You're the front line, I'm the rear line. All right? So he took the fall, he's behind him. Now watch this, it's interesting. This guy dropped so much that now it ran lean. See how it ran lean? So what does he do? He goes back up. Look, he went back up. And here's what's interesting that I never knew. The point at where the short term and the long term cross, what do we have? Fuel control. I never knew that. The point at where they cross, going back the other way, where they cross is where fuel control starts to happen. And look at this. We're still in fuel control. You notice how the long term is still, now instead of going into a ramp, it's going in steps? We're in fuel control. What is the long term trying to do? If you're telling me long term is in charge of O2 switching, why is he still moving? The O2 is switching. What is his job going to be? What is he trying to do? He's trying to bring short term back up to 5%. And look what happened when the long term hit rock bottom to negative 22. Where did short term go? Plus or minus 5. I just proved on this slide that long term wants to control short term. Short term is in control of the O2 switching. There's no doubt in my mind now. I didn't get the whole process. You know, why one guy's going up, one guy's going down. So again, everything's happy here. They're all plus or minus 5 here. When it sees a rich condition, short term goes first. If it's a drastic drop, long term has to help this guy because he's falling too much, right? And then when he starts to go back up because there's a change, the long term levels out. But where they cross, that's where fuel control is. The long term is still going to work to bring this guy back up. I just find that pretty wild. Yes?
The blue and the red are the long term,
Yep.
the yellow and the green are the short term.
Yes. But it's wild how it leveled off right here. It leveled off. It dropped real fast. It leveled off. I said, all right, it looks okay, but now let me just go in steps to control this guy. So a lot of guys go to me, yeah, but I have fuel control. You do, but where's the trims? Where's the trims? Because the long term will never allow the short term to go full. But let's just say the short term was at negative 25 and the long term was at negative 25. You have a major problem. And then your O2 is at flatlined. Well, let's say the O2 is flatlined high or low. There is no fuel control. The trims will both go max. Because if the O2 is not moving, you have a major problem. There is no fuel control.
John, on most scanners, if you got a lot of data pins up, you won't see that short term doing that with the switch. You got to like shut them all off.
Well, see this OB2 generic? So if you use OB2 generic, you have to shut all the other PIDs off and just look at short term, long term, and O2. I do it every car I do. I look at short term, long term, and O2s on their own screen there. Because I don't want to look at everything else because it's going to slow the whole process down.
You won't see it. Yeah.
And also, you ever look at a car that said a lean operation or rich operation, and the long terms are at 25%, let's say positive, to add fuel, and no matter whether you in idle or whether you snap the throttle, whether you power brake it, the long term never moves. It never moves. It's just stuck. What is that? It's stuck in fail-safe mode. You could put a mass airflow sensor in, it's still stuck in fail-safe mode. You have to literally either disconnect the battery, clear the code, or worse yet, you better make sure that your enhanced scanner has a feature that says clear adaptations and go back to 0. If not, you can't. I had certain cars where I disconnect the battery, touch the cables together, clear the codes, and it still says positive 25%. Because I had a BMW like that. I couldn't do it. My friend goes, dude, you have to clear adaptations. What do you mean? You go into the scanner and go in the function procedure, and there it is. Clear adaptations. I did it with set it to 0 like this. Oh my God, I didn't know. I didn't know because that car was fighting me. It had non-volatile memory. It just kept it there. So understand that you can have fuel trim lock. That because when you have a problem, you want to put everything back to 0 and then see if everything's happy. If everything's like plus or minus, if the long term's plus or minus 5 and the short term's plus or minus 5 and the O2s are moving good, it ain't a vacuum leak creating plus 25. Now you power brake it at about 2,000 RPM, all of a sudden everybody starts to climb. Now you know what the problem is. It ain't an idle problem, it's an off-idle problem, most like a mass airflow problem. Now here's the other way. You set everything back to 0, start the car up, runs a little rough, all you see them like climb, and the car smooths out. It's a vacuum leak. But you would not know that if they're locked. So you have to learn how to unlock the fuel trims. A lot of guys don't talk about it, but I see it, so I have to talk about it. So if you have any questions about fuel trim, just come and see me after class because you have to get this down to the science because you're going to be seeing a lot of this. Here's a Chevy pickup, 4.3 liter, no start, fuel foul spark plugs. It's got good spark because pull the wire off, you can hold it against the block, it's spark every time, spark. And then he's got a little spark tester. He checks the KVs because remember that you need 5 to 7 KVs at idle. But when you crank an engine, you need about 25,000 KVs. Tell me you didn't have a 3800 motor when you go to start up cold. Poop pop, had bad coils. But if you ever got it started, it ran pretty good. It did run pretty good. So you need 3 times around normal KVs when you're firing a spark plug in a cylinder because your compression's higher when you're cranking. You're in a pressure cooker. You're trying to jump an air gap in a pressure cooker. Now you're outside the engine, you're like, no problem. You jump it because you only need that many KVs. So you need to use spark testers. So he had a good spark, good compression. So I'm like, let's check for codes. Not that this validates anything because it's OB2 generic, right? So, but there were no codes OB2 generic. I just did basic PID checks. Coolant sensor is good, 78. Air temp is 93. MAP is 30, key engine off. Barrier volts 11.96. Just validating certain pins. Because he said, I think it's running too rich, it's flooding out. I'm like, dude, maybe it's never starting. Because when you go to start a car, some cars will triple the pulse width as you crank. It's called cranking enrichment. If that car never starts, you're just going to keep dumping fuel and dumping fuel. So he thought it was a clog cat. It could be a clog cat too. Because if you clean the plugs, you go to start it, again, you crank it, good compression. But what's happening here is he's thinking maybe the exhaust clogged, and it could be. So you check the exhaust line clogged, now what? And here's the thing. When I was a kid, I used to build a lot of lawnmower engines. I used to love them. I even had one that was a real type one, the little power motor on top. I used to rebuild them, and I used to stick my finger in a hole. I still do that today. And I used to just check for poof. You know, you push your finger out, right? You stick your finger in a hole, and you poof. We have good compression. And then you just go, ooh. So then you hold the wire, do the same trick. You go, ow. You're like, I have good spark. And then if you get really high tech, you have your buddy pull, and you go, ooh, ow. So then your spark is happening after top dead center. Or you do the other way, you go, ow, ooh. And it's happening before top dead center. So you know whether your timer's off, then you go in there and you set the plunger up, do what you got to do. But you don't need to do that, because in today's technology, there's something called a pressure transducer that you can stick in the hole. See, because we have the old system on a 4-cycle engine. We have the suck, the squeeze, the bang, and the blow. This is your vacuum. This is what the compression is. You're squeezing the mixture. Then you have the ignition, the bang, and then the blow. Hasn't changed for many years. So all I do is take a pressure. This is not rocket science. I'm putting a pressure transducer in the hole. So when the pressure comes up, I see something rise, and then down here it's low, and it rises again. Well, that's the piston going up on compression, and on compression here again. That's all it is. So I know that this is compression, and if you want to get fancy, you can set 4 cursors here, equidistant, and you would know that from here to here is 180, from here to here is, sorry, yeah, from here to here is 180, from here to here is 360, because it has to go, sorry, 720. 180, 360, over here is 720. This is 2 revolutions of the crank, right? So this is compression, follow me, and then this is the power stroke, boom, piston came down, then it's going to go back up. This is exhaust stroke right here. This is exhaust. I put my inductive clamp around the wire, and we did it with timer lights. You know, it blinks every time the wire fires, blink, blink, blink. Even in the old days, I used to put the timer light on, crank the engine, and I could watch the indicator and see exactly where it's firing. You could do it, but there's no more indicators anymore. They're gone. So I put the adapter around the plug wire, put a spark tester on it, right? So every time the spark sparks, it picks up the signal, and there it is, right there. These little ones here, they're just noise, kicking back. But here's the real Megillah. Is this thing firing? No, by the way, if I cut these things up in little sections, these are 30 degrees each, right? 1, 2, 3, 4, 5, 6. 6 times 3 is 180. So it should be firing a little bit before top dead center. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3, 270 degrees away from top dead center. That spark is firing 270 degrees away from top dead center. So even though I'm holding the spark and it's sparking, you have no idea when the spark is occurring in that cylinder. It's just pretty cool technology that I could stick a pressure transducer in a hole and put my device around a spark plug, and that's what I got. So now, could it be a timing chain? Have you ever seen a timing chain go bad in a 4.3 liter? Because I haven't seen one jump yet. I haven't seen one. I've seen many distributors go bad where the gear screws up. So I'm thinking, let's pull the cap off and do a rotor indexing. I'll stick my finger in a hole, find top dead center, and find out where the distributor's pointing. Now, can anybody see anything wrong with the picture here? No screws. And they both fell to their death. Now, maybe one fell first, and then the other one got lonely. And he says, you know what? I got to go find my buddy. And let me tell you something. Here's what was really cool about this whole thing. Do you know they found one another? And they were like 2 peas in the pod. How does that happen? How did they fall in the same spot like 2 peas in the pod?
You were still good?
And they looked all right, but that's where they were. But isn't that cool? And then I'm going to show you another one. I have another one. Identical problem, but different end result. And here's the sad part. I can't show the name brand because this is very bad. You should be very embarrassed. Same problem, but it was a rebuilt distributor, okay, from about 2 months old, right? And I'm looking at it. The rotor was intact, and the screws were in there. I'm like, damn it, maybe the gear slipped. So then the guy from the garage went to grab the rotor, and it's spinning. I'm like, how is that possible? It's spinning and spinning and spinning, and then he did something like he did on these. And I went, dude, I never saw that my whole life. How does a rebuilt distributor lose its press fit? What happened that day? Is this what you guys are getting now? So are you the R&D? Are you now the quality control? Because when I was a kid working on cars, everything you got was quality. It was tested. Every component out the door was tested. Now guess what? That dude lost his job. You guys are testing everything. If we put out 100 of these and 20 go bad, we're still making money. So it's sad that this is what our industry has gotten to, that we're getting bad parts. I was mesmerized. I never saw one of these come off a distributor. So this company should be ashamed of themselves. Quality control isn't there. So, you know, just don't say, well, the part's new. You don't know anymore. Can't take anything for granted. My ex-wife used to say, you take me for granted all the time. All right. I thought you were rebuilt. Anyways, so just beware. Just beware. Buyer beware. And here's the last Megillah. Here's the last Megillah. Hope all these stories enhance what you don't know or what you already know, and understand that I tried to build a foundation in the beginning so we can roll along here and understand what's going on. All right? This is a 94 Chevy Camaro, 5.7 liter. The complaint was erratic IAC control surge when hot. I can tell you that this car did have a distributor replacement because it had erratic RPMs, and it just was all dancing all over the place. New IAC motor, new computer. There was just no resolve for this car. And when I went there, I'm telling you, I ran it for 20 minutes. There was nothing wrong with this car. I power braked it. I revved it up. I watched the fuel trims. I watched the IAC motor. I'm like, dude, there's nothing wrong with this car. And I'm watching data. Also, I'm like, what the heck was that? I'm like, I know it wasn't aliasing. I saw it that time. What's the RPMs here? What's up with that? I never revved the engine. It just showed me 5,000. So now, am I going to sit there and keep looking at it? What would you do? Would you graph it? I would graph it too. I would graph it. The Modus can graph. I graphed on the Modus. Look at this. Look at it spike up to 5,000, not once, but 4 times. Look, over here, over there. And look at the IAC motor. It has no idea what to do. It's like, it was going nuts. And I'm like, dude, what the hell kind of job you got me here? I never saw, it's got to be a baddie. I said, dude, the crank angle sensor has to be defective, bro. Because that's the input for the ECM. Dude, it's rebuilt. Yeah, well, look at this. This was rebuilt too, buddy. Yeah, but John, I got it from brand new from the dealer, and that was a $700 job. I had to sell the water pump too. I'm like, we know what, dude, let's put the scope on and check it out. Let's see what's going on. And there we go again. Without the scope, you're not going to see one of these crank angle sensors that move wicked fast. All right? And here's what I want to look at. If you look at a Hall effect sensor, all right, if you were to unplug that connector, you're going to get power, ground, 5 volt, 5 volt. The job of the Hall effect sensor, once it gets powered up by power and ground, its job is to do what I call a who's your daddy. It's got to take one leg and ground it. Go, who's your daddy? Let go. Who's your daddy? Let go. That's how you get the square wave. It's a square wave being toggled to ground. That's it. And usually, when the shutter goes through the Hall effect, right? This is how I remember it. It sounds silly, but it works. It goes, high. It goes around again, high. So whenever it goes through, it's high. Whenever it comes out, it's low. That's the way it works. So that's how it gets its highs and lows when it goes through, right? I'm looking at it, and this is the way this one works. It goes big, little guy, little bigger, still little guy, even bigger, little guy, and biggest, and little guy. That's the way it is at One Revolution. This guy here, there's 360 of these guys at One Revolution. So if you want to really look at them, you have to spread them out. But it looks pretty normal. Car wasn't acting up yet. Now, if you look at this end of the next slide, I want you to see something. What's that Megillah right there? Is that like the unknown soldier? What, is that normal? A false little spike. That would screw me up from a computer going, hey, what's that little guy there? I would add extra RPMs. I would think it's extra RPMs. That little guy there confused the computer. All you need is one guy in that pattern to screw things up. So now, is that a bad crank angle sensor? And then look at this over here. I'm going to show you something. Here's normal vent. Look. I'm on the primary side. Okay? Here's primary. The coil gets grounded. It's like the old days. It's nothing high-tech. And then we hold it. This is the duration of the primary, the primary on time. Then we go over here, dwell time. And then over here, we let go. We get the spike. Primary's over. He's done. But what happens is, when you pull on something, let it go, the energy goes over to the next guy who's secondary. This is your burn time. Okay? Then over here is your spike, your secondary spike, right? So this is burn time and the spike. Okay? Now, let's do something here. Look how the event got screwed up over here. See how these are all equidistant? You see them? They're all pretty much the same. Notice how this little Megillah here, somebody disturbed them. Is there something going on over here I should know about? What doesn't it look like some kind of a spike? Isn't it a coincidence that this guy's hired an arrest and he's creating a problem here? And he's creating a problem over there? Doesn't it look like the same guy? Look, he's over there, he's hired an arrest. I'm like, you know what, dude? Let's check secondary. Because this is not a primary problem, I think it's a secondary problem. So now I go over into and look at secondary pattern. You see this here? Look at number 6. Look how high he is. What's amazing to me is he didn't create a miss. That's what's amazing to me. But understand that it depends how high it goes. Because if you look at secondary voltage, I'm here to tell you. Can you hold this? All right? Secondary voltage is like one piece of rope. This is 1 millisecond. As you get too high, you spend too much time jumping the gap, your burn time shortens. If it goes below 1 millisecond, you'll start to misfire. If it's out here, 1.2. The other guys are, let's say, at 2 milliseconds. This guy shortens up like 1.2. He's kind of high. The first problem he's going to create is kickback noise. Because look, if you're the coil, let's say you're the coil, and you're firing out, that guy can spike back into the primary, and he can even spike back into the distributor. Because look, he's in the distributor cap, right? You have a distributor cap. And then they put the big shield over the whole effect, and he's going, yeah, I'm okay. But then you have a lightning bolt at you. If you're pulling something low, and you see a lightning bolt, if you're outside your yard, and you went to carry wood in the house through a lightning storm, are you going to hold on to the wood, or are you going to run for your life like this? Ah! You run for your life. Screw that, hold me low, let it go. So a moment when it had to spike, it let go. So that spike kicked back into the distributor assembly. And that's been happening for years with distributors. Kickback of high voltage. But what amazed me was he didn't have a misfire to load. I'll guarantee you if that sucker went on the highway and TCC engagement happened, 1-1 ratio, he had to have something. Like something. But you can never reproduce that in drive because you have stall speed. You power brake a trans, there's stall speed. You can't reproduce that. That's why you ever get complaint, I'm on the highway, and the thing will go, you can't reproduce that in a stall. It's impossible. So, and here's the bottom line. Look at this. Hey, dude, nice headers. Look at them beautiful headers. Some guy in a class in Massachusetts, he was like, hey, dude, those are Edelbrock. I'm like, what do you mean? He goes, I know the tag. Those are Edelbrock headers. I'm like, yeah. He goes, but how did they get the air pipe in there? I'm like, I don't know. Dude, let's take a look. Good weld job. They put the air pipe back in there. I thought it was pretty cool. So that was on the left side. Look what happened here. We found a burnt wire from just all the heat. That's a brand new wire. Look at all the heat got on this wire. It did something to the wire, and it actually just got high resistance. It was falling apart. I guess these header pipes, the wires that he bought, the wire set that was in there, couldn't handle them. But what amazed me was high resistance in that one wire wasn't enough to make it misfire, but yet enough to kick back the high voltage because it had to go somewhere. It had to go somewhere. Because if there's resistance this way, it's going to find another path. And that path was back into the distributor. So a lot of these things can happen. Yeah, the wires were in good shape. They're fairly new, but parts do break down. It's just being alert and learning how to do foundational stuff. And that's what my job here was doing, give you guys a wake-up call. And I hope everything you heard here tonight will hit you during the week. All right.